Hey everyone, welcome back to the SaaS Creative channel, and in today's video we're diving into a full stack authentication using Next.js and NestJS with Turborepo. I'll walk you through setting up a powerful and scalable authentication system step by step, and you will learn everything you need to know about authentication in a monorepo of Next.js and NestJS projects. We'll handle most of the authentication part on the NestJS backend and then consume that functionalities in our Next.js frontend. And this is going to be the last video that you'll need to watch on this topic. So let's quickly take a look at the topics that we are going to cover in this video. As I said, we are going to create a monorepo with Turborepo with two projects. The NestJS project, which is going to be our backend project, and a Next.js project, which is going to be our front-end application. So let me take a look at the topics that we are going to cover. We're going to handle the signing up a new user or registering a new user in the backend side. We use Postgres database with Prisma in this project, and then we are going to handle sign in user with a username and password, and then we are going to add Google OAuth login in our NestJS backend API, and then in the NestJS frontend we're going to use this functionality. In most tutorials on YouTube we can find how to set up Google authentication in our NestJS application with help of the Auth, but in this video we are going to handle the Google authentication in our NestJS backend application and then use that functionality in our NestJS application. All right. Also, we are going to protect our APIs with JWTs. We're going to add the refresh token functionalities and also revoke tokens functionality. So after users sign out from our application, we are going to revoke the tokens of the user. So if the tokens of the user are compromised, the user cannot use that tokens to access to our protected resources on the backend side. We also handle the role-based access control in the NestJS side. We add public routes and also cover how to handle NestJS configurations to use env variables in the right way in NestJS application. And also we have more on the NestJS side in this video. On the Next.js side, we are going to create our sign up form and sign in form. We don't use any third-party library for handling the forms in the Next.js side. We just use the useFormState to handle the forms. We write our own server actions and so on. And also we have a comprehensive section about handling these sessions and how to update the sessions in the Next.js side. We're going to keep the user data as well as the JWT access token and refresh token of the user inside these sessions. In the Next.js side, you also learn how to protect your pages. You will learn how to use middleware for authentication purposes. And also, we're going to take advantage of the role-based authorization in the Next.js as well as the NestJS backend side. So these are the important topics that we are going to cover in this comprehensive tutorial. And as a last tip in the introduction, in order to avoid the confusion between these two projects, between the NestJS project and Next.js project, I put the logo of each project on the right upper hand side of the screen. So if you see the Next.js logo here in the right upper hand side, you can be sure that we're in the Next.js project. And if you see the NestJS logo on the right upper side of the screen, you can be sure that we are on the NestJS project. So yeah, with that extra explanation, let's get right into it. Alright, so in the first step, we need to install the Turbo package globally in our machine. So I'm going to say npm I turbo -- global. Okay, now we can create our monorepo with Turbo. So here I'm going to say npx create -turbo at latest. And then since we are going to create our Turbo repo in the current directory, I just put a dot here, choose the package manager, and we need to wait until it downloads the necessary file. As you can see, it creates two Next.js projects for us inside the apps directory. The first one is docs and the second one is web. We're going to use the web project as our front-end application, and then we are going to create a NestJS project in this monorepo after installing the dependencies. All right, it's done. And here inside the apps directory, as I said, we have a docs and a web project. So as I said, we don't want to use the docs project, so I just remove that. And here now we have just a web project, which, as I said, is a NextJS application. And now in the next step, we need to create our NestJS project. So let's clear the terminal and I go to the apps directory. And next we are going to install the NestJS CLI globally. So here I'm going to say npm i-g at nestjs/CLI. All right, now we can create our NestJS application. So here, as you can see, we are in the apps directory, and now I'm going to create our NestJS application inside the apps directory. So here I'm going to say nest new, and then we're going to name it API. All right, so just choose the package manager. All right, it's done. And if I go to the apps directory, now we have an API directory, which is actually the NestJS application, our backend application actually. And we have the web project, which is our NextJS application, our front-end application. And now here in the terminal, I say npm run dev. It actually looks for the package.json file inside the both projects and look for the dev script here, and then run the script corresponding to the dev script. And here, as you can see, we have the web application running. It's a Next.js project, but it doesn't run the NestJS application. That's because here in the package.json of the NestJS application, we don't have a dev script. We have a start :dev for starting the project. We just need to change it to dev. And if I save that here, let's stop the terminal. And now if I run the npm run dev, we have an error for the API project, our NestJS project. And that's because it tries to run the application on the port 3000, and this port is already taken by the NextJS application. So I go to the main.ts file inside the src directory and change the running port to 8000 and save this. And as you can see, the NestJS application is running. So let's just restart the server. So first, let me just clear this up. Okay, now let's run the npm run dev. And as you can see here, we have the API project up and running. And also here, we have the web project up and running. We can navigate between the console of these two projects with the arrow keys on our keyboard. So yeah, we have created our monorepo with a NestJS and NextJS project with Turborepo. And in the next step, we're going to set up the Prisma in our NestJS application. In this section, we are going to add Prisma in our NestJS application, our backend application. So I open up the terminal and I go to the apps directory and then API directory, which contains our NestJS application. And here we're going to install the Prisma. So I'm going to say npm I Prisma and then -d because it's a dev dependency. All right, it's done. And if I go to the node modules directory inside the APIs directory, you can see it does not contain the Prisma. The Prisma is installed in the node module directory inside the root path of our Turborepo. So if I scroll down here, we can spot the Prisma here. So actually we can use the packages that we install in our Turborepo in all of our projects inside the Turborepo. That's one of the benefits of using Turborepo for creating a monorepo. We can share the packages between the projects. So back to our project, and now we need to initialize the Prisma. So here in the terminal, I'm going to say npx Prisma and then init. It will create a Prisma directory inside our NestJS application, and it creates the env file. The env file now contains the database URL variable. We need to put the URL of our Postgres database. I didn't mention that we are going to use Postgres database in this project. So we need to put the URL of our Postgres database here. And if I go to the Prisma directory, we have a schema. And inside this schema, we have the data source DB. It actually specifies the database that we are going to use. It's Postgres. And then the URL of that database is going to be from the env file and database URL variable. And after this, we need to define our database model, actually database tables. And after that, we need to run a migration to create the tables inside our physical database, our Postgres database, based on the models that we are going to create in this schema. But there is another way, which is called introspection, and this is especially suitable when we have a physical database with its table in advance. So here we have a database, and this schema actually describes the database that we have in advance. This database is on Neon server, and actually we are going to create our Prisma schema based on this table and their relationship. So as I said, this is called introspection. But before doing that, let me quickly show you the difference between migrations and introspection. So in migrations, actually we already have our schema in place, and we are going to create the tables inside our database based on the models that we have defined in our Prisma schema. On the other hand, when we have our database in place with its table, and we are going to create our Prisma schema based on the tables and their relationships inside our database, we are going to create a introspection. So now in this project, we have our database in place, and we are going to do a introspection in order to create our Prisma schema. So I go to the Neon console and sign in into my account, and here we have a project. If I go to the tables, you can see we already have our tables in our database. So I get back to the dashboard and copy the database URL here, and then get back to our VS Code. I go to the env file inside our NestJS project and replace the database URL here. All right, let's save this, and now we are ready to run our database introspection. So let me maximize the terminal here, and I just say npx prisma db pool, and then run that. As you can see, it is introspecting based on the data source that we provide our env file, and it's done. If I get back here to the database Prisma schema, you can see now we have our model in place here in our schema.prisma file. They are created based on the database that we have provided its URL inside our env file. That easy. So now we need to run a Prisma generate command to create the types and Prisma client for us. So I just say npx prisma generate, and it's done. So as you can see, things are really easy with Prisma. And as a last step in this section, we need to create a Prisma service. So here I'm in the NestJS project apps/API, and now we can use the Nest CLI here, Nest G and then S, which stands for service, and then create a service named Prisma. All right, as you can see here inside the srt directory of our NestJS application, now we have a Prisma directory, and inside it we have a Prisma.service. And all we need to do here is to create a Prisma client class and export it from here. And then in other services, we can use this Prisma service, which actually is a Prisma client, to access to our Prisma database. So to speed up the process, I just copy a snippet from the NestJS documentation and paste it here. It actually exports the Prisma service, which actually extends the Prisma client, and then it needs to implement the on module init. The on module init should have a async function on module init, and every time this module is initialized, this function will be run. And as you can see, we're going to use this.connect function, and since we extend the Prisma client class, we have a connect function in this class, and on module init, we are going to run it to connect the Prisma to our Postgres database. So that's it for Prisma section. Now we can import this Prisma service in other services to access our database and do CRUD operation with our database. That's it. In the upcoming section of this video, you will see how we can do that. Alright, in this section, we are going to create a sign up API for registering a new user in our backend application. So this is going to be the whole process of user registration process in our Monorepo. In our NextJS front-end application, user fill up the sign up form, and the sign up form will actually send a post request to the /auth/signup. So let me fix that here. It should be auth and then sign up. All right. So in the sign up API, we're going to get the user data within the body of the request and then save the user data into the users table of our database. So now let's implement the /auth/signup API in our NestJS application. I get back to the VS Code and let me open up the terminal. And here, first we need to create an auth module. So I'm going to say nestg module. Actually, let me create a resource because we are going to create the module controller and its services. So I'm going to call it auth and then --nospec because we don't want to create the test files. We're going to go ahead with REST APIs and we don't want to create the CRUD entry points. So as you can see, now we have an auth directory here. Inside it, we have an auth controller, auth module, and a auth service. And then inside the auth controller, I'm going to create a post endpoint for sign up. So I'm going to use the @post decorator and set its route to sign up. You can also set it as register. Some developers prefers to use a register instead of the sign up. And then I'm going to create a function for it. I'm going to call it register user. Now here we need to get the user data from the body of the request. So I'm going to create a DTO for typing and validation. Inside the auth directory, I'm going to create a directory called DTO, and then inside it, we're going to create a file named create user.dto.ts. So I'm going to export a class, call it create user DTO. And for validation, we need to install the class validator and class transformer. So I'm going to say npm i-d class-validator and class-transformer. Let's install these two dev dependencies. Right now, here we can enforce the validation. The DTO for creating a user should have a name, which is going to be string, and let's put the is string decorator for it. And then we're going to have an email. It is going to be a string and also an email. So I use is email as well as the is string. Then we're going to have a password, which is going to be a string, and it is going to be string as well. We can enforce other validation for password like min and max length, special character here in the is string. So let's just keep it simple here. And then we need to go to the main.ts file and enable the validation globally. So I'm going to say app.use global pipes and then pass create a new instance of validation pipe class and pass the config object, set the transform to true and set the whitelist to true to stripe out unnecessary properties inside the body of our request. So let's get back here in the auth controller. Now we can use @body decorator to get access to the body of the request, and then we're going to have a create user DTO and set its type to the create user DTO class that we have just created. All right, we forgot to put the parenthesis of the body decorator, and now inside this function we're going to call the auth service. So here just return auth service dot register user function, which we haven't created yet. We're going to create in a second and pass the create DTO class. So now let's just declare this function inside the auth service class. So here, first we need to look up in the user table. We need to check if the user that we are going to insert in the database is already inside our user table. If that's the case, we're going to return an error to the client. Otherwise, we just insert the user into our database. So for doing the CRUD operation for the user table, I prefer to create a separate module for the user. So here I'm going to say nestg res user, and then --nospec. We have a typo here, so let's fix that. We're going to go ahead with REST API, and we want the CRUD entry points. All right, so as you can see, we have the user module here. It has the DTO inside it. We already have the create user DTO. So let's just delete the create and update user DTO and move the create user DTO here in the user module. And we don't want the entities since we are using the Prisma. And here in the user service and in the controller, let me remove this endpoint and I go to the user service. Let's just import the create user DTO and remove all the functions except the create function. We're going to use that in a second, but before doing that, we need to inject the Prisma service. So in the constructor, we're going to have private read-only Prisma, which its type is going to be from Prisma service. All right, let's put the body of the constructor, and before writing the create function, let's have a function, actually an async function, find by email. It takes the email, which is going to be a string, and then use the Prisma service, this.prisma.users.find unique, and then in the config object, we're going to set the where object and pass the email to it. We have an error here for the where object, and that's because when we use the find unique function, we can only use the unique field inside the where API. So I go to the Prisma here, and for the email of the user, we use @unique decorator. Save this, get back to the user service. All right, the error is gone. You may need to run npx prisma generate in your terminal if the error is still there for you. So now let's write the create function. So here, first we can use prisma.create function to insert the user into our database. But before doing that, we need to hash the password of the user. So for doing that, I'm going to install a package called argon2. So here I'm going to say npm I argon2. You can also use bcrypt for hashing your password, but the algorithm of the argon2 package is newer and faster. So we're going to use argon2 package. So first we need to get the password of the user from the DTO. I'm going to use the structuring here, and from the create user DTO, we're going to get the password and put the rest to a user constant. All right, now we can hash the password. I'm going to say const hashed password and call the hash function of the argon2. So here I'm going to use hash function, which comes from the argon2, and then pass the password of the user. Now we can call the Prisma client. So we're going to say return await prisma.create function .users.create, pass the config object and specify the data. So inside the data, we need to pass a user object. So first we need to set the password to the hashed password and then spread the user here. And since it is a async function, we need to mark it with async, and also the hash function is an async, so we need to wait for that. All right, now we can get back to the auth service and write our register user function. So here first we need to check if the user is already inside our database or not. So here I'm going to say const user and then call the find one function by the user service. So we need to inject the user service here in the constructor. I'm going to say private read only user service and set its type to the user service. And since we are going to use the user service here, we need to go to the auth module, and in the providers, we're going to register the user service in the providers list. And also we're going to register the Prisma service as well. Get back to the auth service and register user function. Now we can use the user service find by email function and pass the create user DTO.email and then check if the user is not undefined. It means that the user is already in our database with this email. So we're going to throw a new conflict exception with the message user already exists. Otherwise, we can just return this .userService.create function and pass the create user DTO to it. So yeah, we're done with creating the sign up API in our NestJS application. So let me do a quick recap here. We have created the sign up post endpoint in the auth controller, and it calls the auth service.register user function. And first we check if the user is already inside our database with this email. We just throw in conflict exception, and otherwise we just insert the user with the user service.create function. Now in the next section, we need to go to the Next.js application and create a sign up form. And then from that sign up form, we are going to call the sign up API of our auth module here in the Next.js application. Alright guys, now in this section we are going to create the sign up form for registering a new user in our Next.js application, our front-end application. So I go to the web directory inside our Monorepo. This directory contains the Next.js application, and I go inside the apps directory. And now let's create a route here. I'm going to create a directory. I'm going to call it Auth. In this directory, we're going to put the Auth pages. So inside it, first we are going to create a layout. So I create a layout.tsx, and inside it, let's create a component. I'm going to call it Auth layout. And here in the props, we need to get the children. So here, set the type to props with children, which comes from the React. All right. Now here we can grab the children, and inside this div, we're going to render the children. And to speed up the process, we are going to put some Tailwind CSS classes here for styling the layout. It just create a gradient background on our layout. So let's save that. And now we are going to create the sign up page. So inside the Auth directory, I'm going to create a sign up directory, and inside it, we're going to create the page.tsx. Let's zoom in, and here first, let me create the page. I'm going to call it sign up page. All right. Again, to speed up the process, I just paste the JSX for creating the sign up page, and let's import the next link here. We're going to have a container div and an h1 which says that this is a sign up page, and here we are going to put the sign up form. We're going to do that in a second, but after the sign up form, we have a p tag which says if you have already an account, you can just click on this link, which leads you to the /auth/sign-in page. Obviously, we haven't created this route yet, but we're going to create it in the next section of this video. But for now, let's just leave it as it is here. So now let's run the Monorepo. Here, as you can see, I'm in the root path of our Monorepo. So I'm going to say npm run dev. You can see we have the Next.js application running on port 3000. Let's just open that and go to the /auth/sign-up. So as you can see, we have the sign-in page here, but the Tailwind CSS styles are not applied here. And that's because the Turborepo does not install the Tailwind CSS in our Next.js application out of the box. So we need to install the Tailwind CSS. So I go to the Tailwind CSS documentation and go to the section for installing inside the Next.js application. So we need to copy this to command, get back here and open up a new terminal, go to the apps.web, and here let's install these two commands. All right, it's done, and we need to get back to the Tailwind CSS here and copy this section. We don't use the src directory, so we don't want to copy that. Get back to VS Code and go to the Tailwind CSS.config file and paste it here on the content list. Actually, we don't want to use this because we're using the app router. Let's just leave it as it is. And again, just quickly go back here, copy this, go back to global.css file. We don't want these default CSS. Instead, just paste the Tailwind commands. So now let's get back to our application. And yeah, as you can see, now the Tailwind CSS classes are applied and we have the sign up page. Obviously, we need to fix that and replace it with sign up page here in the h1 element. And then after this title, we need to create our sign up form. So let's get back to our VS Code, and here in the sign up page, let's change the title to sign up. And now we need to create a sign up form. So we are going to create a sign up form component here next to the sign up page and then use that component here. But before doing that, let me first install the ShadCN UI because I'm going to use some components of ShadCN UI here. So let's open up the terminal and let's create a new terminal and go to the ShadCN UI documentation. Here, don't go to the Next.js because we have a Monorepo. So just go to the CLI section and here scroll down to the bottom section. Just copy this because we have a Monorepo. Copy this command, get back to our application and paste it here. We just need to set the path of the Next.js application to the apps/web. So let's run that. It complains about we don't have a import alias in our tsconfig file. So let's go to the tsconfig file of our Next.js application. Here we have the tsconfig file. Let's open that And in the compiler's options object here, we are going to paste the base URL and then define import alias here. I'm going to use path, and then inside it, we're going to define the import alias and set its path to just current directory and then everything inside it. All right, so let's save this and get back to our terminal again. Let's run the previous command for installing the ShadCN UI. As you can see, now it's working. Just go with the default options and wait for it to install the dependencies. All right, it's done. Now let's get back to ShadCN UI. We want the button element. So let's just copy the script for installing the button element, get back to our application. And first, let me clear this up. It is important here, after installing the ShadCN UI, we need to go to the Next.js application apps/web. And then here, we need to run that script for installing the button. If you don't do that, we got an error. That's because it looks for the components.json file, which is in the apps/web directory, our Next.js application. So as you can see, it creates a lib directory for us and create the cn function and also the components directory. And inside it, we have the UI. And then inside it, we have the button.tsx file. So now let's get back to the ShadCN UI and install the label and input element. I just copied the command for installing the label, paste it here, and then just paste the command for installing the input. You can find them in the ShadCN UI documentation. So we're done here. As you can see, we have the button, input, and label. So let's close this off and then go to the sign up directory, and next to the page.tsx, our sign up page, let's create a new file, the sign up form component. So I'm going to call it sign up form.tsx. And then create a functional component here. Just name it a sign up form. And to speed up the process, let me just paste the basic JSX for this sign up form. And let's import the label from the components directory and then UI and then label file, and also import the input element from the same directory. Now let's get back to the page.tsx and paste the sign up form here. All right, now let's get back to our application. And here, as you can see, we have a name, email, and a password. So we need to put a submit button here. Let's get back to our VS Code and I go to the sign up form, and here we need to put the submit button. But since we are going to use the useFormStatus hook of React, I'm going to create a separate component for submit button, use the useFormStatus, and then put it here. So inside the components directory, in the UI section, I'm going to create a new file. Let's call it submit button.tsx. And here, let's create a component and I'm going to call it submit button. And first we need to have children. So again, let's use the props with children type of React and then extract the children here and then turn this div to a button element. So we import the button from the same directory. It's a ShadCN UI button. And then before returning the JSX, we're going to use the useFormStatus. So here I'm going to say const for now an empty object and use useFormStatus, which comes from the React DOM, and from the returning object, we're going to use the pending property. So you just define the pending property is true when the parent form of this submit button is on the pending section. So it automatically looks for the immediate parent form and set the pending value based on the pending status of the immediate parent form. So here, first we're going to set the type to submit, all right? And then we're going to set the area disabled based on the pending. So we're going to set it to pending that we've got from the useFormStatus here, and also set some Tailwind CSS class names, w full, and let's just use empty 2 for some margin from the top element. And then here, let's set the caption of the button conditionally based on the pending value. So if the pending is true, we're going to just put submitting, and otherwise we just use the children. The children must be a text caption, for example, sign up or sign in. And if the pending is true, no matter what is the children caption text, we just render submitting text as the caption of this button. So let's save this and get back to our sign up form. And here, let's just put the submit button and set the caption to sign up. Let's save this and get back to the browser. You can see we have a compile error on useFormState, and in order to fix that, we need to set the submit button component to a client component. So get back to VS Code and go back to the submit button and mark it with use client directive. Now get back to browser. As you can see, the error is gone and we have the sign up button. So now we need to set the form action for this sign up form, and inside the form action we need to send a post request to our backend API, sign up, and send the user data to the backend API. All right, so let's do that. Let's get back to the VS Code and go to the sign up form. And here we're going to use the useFormState for submitting the form. But before doing that, we need to create a server action for sign up form. And then we can use that server action inside the useFormState. And by the way, inside the server action, we are going to send the post request to our backend API. All right, so now let's create the sign up server action. Inside the lib directory of our Next.js application, I'm going to create an auth module, auth.ts, and then here first we're going to mark it with use server directive. So now every function in this file will be a server action. So now let's create and export the sign up server action. Export async function. I'm going to call it sign up, and then if we are going to use this sign up server action with useFormState, we need to take two parameters. The first one is the previous state of our form, and we're going to create a custom type for it based on our sign up form. And the second one is just the form data that is going to be collected from the sign up form. Now we need to create a type for our form state. So here inside the lib directory again, I'm going to create a file and call it type.ts. And inside it, we're going to export a type form state. So what is the form state? It is actually contains an error object and a message string. So if I get back to the sign up form, you can see we have three inputs. The first one for the name of the user, the second is for email, and the third for the password. So we're going to have an error object that contains the error message for each of these inputs. And when we call the sign up server action for submitting the form, we are going to validate the values of the form data. And if there is a validation error for each of these inputs, we are going to set the corresponding property of the error message with a proper message string. So let me create the form state type and you will see what exactly I'm talking about. So as I said, it is going to have an error object which can be undefined, which is optional, and inside it we're going to have a name which contains the error message if we have an error message for the name input. Again, it should be optional and set its type to string. We need to have an email which contains the error for the email, and also a password which is going to be a list of string because our password error might have multiple errors inside it. All right, now we have a typo here. We need to put the question mark before the colon, and then we're going to have a message property which again is optional and its type is going to be string. We're going to set this message if we have an overall message that we are going to show to the user after submitting the form, and also it might be undefined. All right, so let's save this and get back to our auth.ts file where we are going to create our sign up server action and set the type of the state to form state type that we have just created. Okay, and then it will actually return a promise that eventually resolve to a form state. So eventually it returns a form state. So now inside the sign up server action, first we need to validate the form data. It should have name, email, and password inside it. So again, I get back to the types directory and create a ZOD schema for that. So before doing that, we need to install the ZOD package. So I get back to the root path of our Turborepo, all right, and then just install the ZOD package. All right, it's done, and now we can get back here, and to speed up the process, we just copy the sign up form schema and paste it here. And let me just import the ZOD, and it should have name, email, and password, and these are the rules that the password should follow. All right, so let's get back to the auth.ts and our sign up server action, and now we can validate our form data with the sign up form schema. So here I'm going to say const validation fields equals to sign up form schema dot save parse, and then pass an object here. We're going to have a name and set it to form data.get and then pass the name. In the same way, we're going to have email and we're going to have the password. And then we're going to check if this object does not satisfy the sign up form schema. So we're going to say not validation fields dot success. Then we're going to return form state object that has some error inside it. So just return an object that contains error and set it to validation fields dot error dot flatten dot field error. And then we have an error here, and that's because we should set the type of the name and email inside the error object to a list of string. As you can see, the error is gone. And then after the validation phase, we need to send a post request to our sign up API in the backend section and then pass the name, email, and password of the new user to that endpoint. And that endpoint will actually insert a new user into our backend database. So first, let me create a constant file here, constant.ts, and then here inside it, we're going to export a constant which contains our backend URL. So I'm going to call it backend URL, and we're going to read that from the env file. So I'm going to read it from process.env.backend URL. All right. Now let's go to the env file. Actually, we don't have an env file, so let me just create a .env file in the root path of our Next.js project, and inside it we're going to have a backend URL and set it to the localhost port 8000, which is actually the address of our Nest.js application. So now let's get back to the auth.ts file, and in the sign up server action, now let's send a post request to our API. So here I'm going to say const response and set it to await and use the fetch API here. And as the address, we're going to put the backend URL and then /auth and then sign up, and then pass a config object, set the method to post because it's a post endpoint, and also set the headers and set the content type to application.json and set the body to the validation fields.data. So we need to use the json.stringify and then pass the validation fields.data. And then we're going to check if the response is okay. We just redirect the user to the /auth and then /signin. All right. We haven't created this route in our Next.js application, so we're going to do that in the next section of this video. But here, if the response is okay, it means that the user is successfully inserted into our database, and we need to redirect the user into the sign-in page so the user can sign in with its email and password. So here we have an error, and that's because we have imported the redirect function from the wrong path. So let's import it from the next/navigation. Right now, if the response is not okay, we need to return back a form state object with a error message to the sign up form. So in the else, we're going to return a form state object, and this time we're going to set the message, and we're going to check if the response.status equals to 4 or 9, which means that we have a conflict exception error. We're going to return the user is already existed. All right. Otherwise, we just return the response.status text. So here, to remind you why I put the 409 here, I just go to the auth service of our Nest.js backend application. And here, as you can see, we find the user by its email. And if it's not undefined, it means that it has already been saved in our database. So we throw a conflict exception, which actually return back a 409 error to the client. That's why in our Next.js application, we compare the status code to 409. All right, so we have the sign up server action in place, and now we can use the useFormState in our sign up form. So I get back to the sign up form, and here we're going to use the useFormState. So here I'm going to say const for now a empty array and set it to useFormState, which comes from the React DOM. And here in the first parameter, we need to pass our server action. So pass the sign up server action, which comes from the /lib/auth file. And then as the second argument, we need to pass the current state of our form. We're going to just put the undefined for the current state. And then here in the returning array, we can have a state, which actually the returning object of the sign up server action. And then we can have a form action. So just call it action. And now we can use this action for the form action. So I set the action of the form here to the action that we've got in the returning array of the useFormState. So again, our server action that we are going to pass in the first parameter should take two parameters: the previous state, which we're going to have pass here, and a form data. So if I get back to the sign up form, we can see we have the previous state and a form data in the parameter. Otherwise, we cannot assign the sign up to the useFormState. In the second parameter of the useFormState, we're going to pass the previous state of the form, which eventually will be passed as this parameter to the signup function. This will be done by the useFormState under the hood. And then we get a tuple here. The first member is actually the returning object of this server action that we pass here. And the second one is just a function that takes the form data. All right. So we can pass it easily to the action event of the form. That is done by the useFormState. Also, we need to mark the component as useClient because we're using the useFormState here. That's a hook from the React, and we should mark the component with useClient. So again, let me recap here. When the user click on the submit button, this returning action will be called, and the component will be re-rendered after the action will return. And in the second render, after submitting the form, we will get back the state object, which actually is the returning object of the sign up server action. It could have some error about the validation, or a message says that there is an error on the backend server. All right, so now let's get back to the sign up form, and here in the form we can check if the state.message is not undefined. We can just render the error message on the form. So I just use a p tag here and render the state.message here. I also need to use some Tailwind CSS classes for the p tag. In the same way, for each input, we're going to check if the state.error. For example, name is not undefined. We're going to render it below its corresponding input. So here, after the name input, we're going to check the state.error.name, and if it's not undefined, we're going to just return a p tag just like this and put the state.error.name on the screen. Let's just do the same for the email. We're going to check if the state.error.email is not undefined. We're going to render it on the screen. And for the password, since we might have multiple error messages, we're going to render all of them in the sign up form after the password input. So here, after the password, we're going to check the state.error.password, and if it's not undefined, we're going to render a div, and then inside of it, we're going to render a p tag and say password must the following error. So after the p tag, we're going to render a ul unordered list, and inside it, we're going to loop through the password. So here, I'm going to say state.error.password.map get the error, and for each error, we're going to render a list item and set the key to just error and just render the error itself. All right, so let's save this and get back to our sign up page and submit the empty form. As you can see, we have error on the name, email, and password. So let me get back here and put some Tailwind CSS classes for error on the password. Get back to the VS Code, and here the parent div that contains the errors of the password, set the text size and text color. Now let's get back to our sign up form. As you can see, we have the validation error on the sign up form. So this is the way that we can use the useFormState in React and Next.js for handling the form without using the third-party libraries like React Hook for, which is actually a great library, by the way. Now let's get back to the VS Code and check the console of the Nest.js application. We have an error, and that's because we need to register the Prisma service in the user module. So let's get back to our Nest.js application, and in the user module, we need to register the Prisma service here. All right, let's save this, open up the terminal again, and as you can see, we don't have any error. So let's get back to the browser and put some data inside the form. Let's just put some dummy data here and the email and also the password. So let's just put a complex password here and click on the sign up, and it says the user is already existed, although we don't have any data in our user table. So let's get back to the Nest.js application, our backend, and go to the auth service here, and let's go to the user service.find by email. And yeah, we didn't return the returning object of the find unique, so we need to return and await for the find unique function. Let's open up the terminal. All right, the NestJS is running. Let's get back to our browser and submit the form again. And as you can see, we have been redirected to this /auth/sign-in page, which we haven't created yet. And this means that the user is successfully inserted in our database. So let me just open up the Prisma Studio to check if the user is in our database or not. So let me create a new terminal, go to the apps, then API directory. Here I'm going to say npx Prisma Studio, go to the users table, and as you can see, we have a user inside our users table. And here, as you can see, the password is hashed with the Argon2 package. So yeah, that's it for the sign up functionality in our Monorepo. And in the next section of this video, we are going to create a login API or sign in API in our backend application. And then in the front end application, our Next.js application, actually, we are going to create the sign in form for our application. So let's do that. But before moving forward to the next section, if you have watched up to this point of this video, please hit the like button to support me grow faster on YouTube. I really need your help to grow on YouTube, and I really appreciate all your support. Also, if you haven't subscribed to my channel, I have a lot of comprehensive courses on Node.js frameworks, especially on NestJS and Next.js, so you can subscribe to my channel to get informed about the updates and future courses on my channel. Again, thanks for supporting me and this channel. All right, in this section, we're going to create a login or sign-in API in our backend application. So I get back to the NestJS application. Here, I go to the Auth controller. We need to define a route for sign-in. So it's going to be a post endpoint and set its route to sign in. So it would be on the /auth/sign-in in the backend application. And I'm going to call the function login. And then here we need to configure the local strategy of the Passport package for handling the login with username and password. So as I said, I'm going to use the Passport library for authentication in our NestJS application, which is a really great and powerful library for implementing authentication in Node.js backend application. So let's open up the terminal, and here let's create a new terminal. Let's go to our backend application, and here I'm going to install the Passport library. So I'm going to say npm I at nestjs/passport, the Passport library, and then Passport local strategy. All right, so let's install these three packages, and then we need to install the types of the Passport local. So I'm going to say npm I-d add types/passport-local. All right, it's done. So let's close the terminal. But before creating the local strategy, let me quickly explain the entire process of authentication when we are going to sign in with a username and password. So let me show you a diagram here. First of all, when we authenticate our user with a username and password, we call the strategy local strategy. That's because we actually keep the username and password of our users in our backend local database. So that's why it's called local strategy. So in the local strategy, first user in the Next.js frontend fill up the sign-in form. And then in the sign-in form, we're going to send a post request to the /auth/sign-in of our backend NestJS server. Then we have the sign-in API, which we have just created a few seconds before. And then we're going to create a local auth guard, which actually is a guard that sits before the sign-in API. So the post request of the client first is sent to the local auth guard. And actually, as you can see, it keeps the sign-in API. And then in the local auth guard, we're going to activate the local strategy. In the local strategy, we extract the username and password of the user from the body of our post request, and then check them with our database to see if the user has provided a correct username and password. If that's the case, which means that the username and password are correct, we're going to create a user object in the local strategy and append that user object to our request object and send the post request here to the sign-in API. And then in the sign-in API, we just create our JWTs and send them back to the user. So this is the whole process of signing in with a username and password. And here, if the username or password is not correct, we can just return a unauthorized error here in the local strategy. So now first we are going to create a local strategy and a local auth card. So let's get back to our application. Here in the auth controller, we have already created our sign-in post endpoint, which calls the login API. Now we need to create a local strategy and local auth card, and then decorate this API with the local auth card. So when the client send a post request to this API, we're going to activate the local auth card first, and then if the username and password are correct, we can allow the user to access this API. So now in the first step, we need to create a local strategy. So in the auth directory here, we're going to create a strategies directory. And inside this directory, we're going to create our passport strategies. So we're going to create local.strategy.ts. And here note that the name of the directory strategies is up to you. You can name it whatever you want. And also the name of this strategy is up to you. You can name them whatever you want. So now let's export a class. I'm going to call it local strategy, which needs to extend the passport strategy. It's a function that comes from the NestJS passport, and we need to pass the local strategy of the passport local package. So here we're going to pass the strategy, and as you can see, the strategy should be imported from the passport local. All right, now in the constructor of the class, we're going to call the super function, which is actually the constructor of the local passport strategy class here. And then inside it, we're going to specify the username field, which in our case is the email. So as you can see, it doesn't have the autocomplete. So in order to access to the autocomplete here, we're going to just create a dummy class here. We'll call it just S, set it to new strategy that comes from the passport local here, and then pass the config object to the constructor. And here, as you can see, now we can access to the properties of the config object. So we need to get the username field, just copy that and put it here and set it to email, because we're going to use email as our username field. All right, let's just remove this dummy class. And then after the constructor, we need to implement a validate function, and it takes the email, which is going to be a string, and a password, which is also a string. So how we can get the email and password? Actually, when the local strategy is activated by the local auth card, it looks inside the body of the post request and actually extract the email, which we have specified here, and a password. And if our password field is something different, we need to specify password field in the super function. So it actually extract the email and password from the incoming post request to the sign-in API, and then pass it to the validate function. And here we need to actually validate the email and password of the user. So we need to check inside our database to see if these credentials are correct or not. So for doing that, we need to create a validate user function in the auth service, and from that we're going to check the email and password. So first, let me inject the auth service in the constructor here. So I'm going to say private read only auth service and set its type to auth service class. All right, now here we're going to return the auth service that validate local user. So we haven't created this function yet. We're going to create it in a second. Well, let me just pass the email and password to it. All right. So in this function that we are going to create, we need to check the email and password of the user and then return a user object. And as you can see, the returning object will be returned from this validate function. And it is really important for you to know that the returning object of this validate function will be appended to the request object. So later we can access to the user object from request.user. You will see how we can access to the user object at the end of this section. But for now, let's just remove that and create the validate local user in the auth service. So let's just cut that from here and paste it here. All right, so first let me mark it with async. And now in the first step, we need to look up our database in the user table to see if we have a user with this email. So we're going to say const user, and we're going to use the user service here. We already have injected the user service into this class, so we can use that user service user.find by email function and pass the email parameter to it. So now we're going to check if the user is undefined, which means that we don't have a user in our database with this email. So we can check if not user, which means that the user is undefined. We immediately throw an unauthorized exception. So we're going to say throw new unauthorized exception and set some message to it. For example, user not found. All right. Otherwise, if we find the user with this email, we need to check its password. So as you know, the password inside our database are in the hashed form. So for checking the password, we're going to use the Argon2 package to verify the equality of the password that we have here in the parameter and the hashed version of the password that we've got from our database. So I'm going to say const is password matched and set it to verify function, which comes from the Argon2 package. And then in the first parameter, you need to put the hashed version of the password. So we're going to say user.password. So we forgot to put the await here, right? It is really important to put the await here, because if you forgot to put the await here, this function just return a promise. And when we check the user, if it is undefined or not, it is always a true value, which means that it's not undefined. That's because we've got a promise instead of the user object. So put the await here, and then we can use the user.password here. And then in the second parameter, we need to pass the plain password that we have in the parameter of this function. So now we need to check if the password is not matched. We're going to return an unauthorized exception again. So here, we're going to say if not is matched password, then we're going to throw a new unauthorized exception again and pass the message as something like invalid credentials. All right. So if we pass this exception trap here, it means that the user has provided a correct username and password in the body of its post request. So we're going to create a user object and pass it to the validate function. So we're going to return an object which contains the ID of the user. I'm going to set it to user.id, and let's put the name of the user here and set it to user.name. All right, now let's get back to the local strategy. And as you can see, we just returned the returning object of this validate local user from this validate function. And as I said, it will be appended to the request object under the property name user. All right, we're done with the local strategy, and now we need to create the auth guard for the local strategy. So let me clear the terminal, and here I'm going to use the nest CLI for creating a guard. I'm going to say nest GU, which stands for guards. And we're going to put it in the auth and then guards, and then put its name as local-auth. Right? As you can see, it creates a guards directory inside the auth module, and inside it we have a local auth, and then inside this directory we have the local auth.guard.ts file. Now let's open the local auth guard, and here we don't need this implement can activate. We just need to extend the auth guard function, actually the returning class of the auth guard function, and then just specify the name of the strategy, which is local, and then put the body of the class. So the auth guard function comes from the @nestjs/passport, and here we need to pass the name of the local strategy, which by default is local. Let's save this, and now let's get back to the auth controller in the login API. Now we need to use useGuards decorator and pass the local auth guard that we have just created. So when the client sends a post request to this API, it first goes through the local auth guard, and the local auth guard activate the local strategy, and inside the local strategy, we're going to extract the email and password from the request body and pass it to the validate local user, and this function will return an object that contains an ID and the name of the user. This object will be returned from the validate function, and as I said, will be appended to the request body under the property name user. If the email or password is not correct, we just throw an unauthorized exception, and actually we do not allow the user to access the sign-in API. So now here in the login function, we can access to the request decorator, which comes from the nestjs/common, and we can call it rec, and here we can just return rec the user, right? As I said, this user property from the request is appended by the validate function inside the local strategy. This is for the sign-in API, and in the upcoming section of this video, we are going to generate the access token and refresh token for the user and then send them back here instead of just returning the user to the client. And then in our Next.js application on front end, we need to create a session and keep those JWTs inside the session. And with these JWTs, we can protect our other APIs in our NestJS backend application. I'm going to show you in the upcoming sections of this video how we can implement that. But for now, we need to go back to our Next.js application front end and create a sign-in page so the user can fill up the sign-in page, and then we can send a post request from that sign-in page to this sign-in API. Alright guys, now let's go to the Next.js project in the web directory, and then inside the app directory and then auth, we're going to create a new route. I'm going to call it sign in, and then inside it, we're going to create the page.tsx. Right, so let's create the page component here and name it sign in page. And again, for speed of the process, let's just paste the basic boilerplate JSX for the sign in page. All right, now let's get back to the browser. As you can see, we are on the /auth/sign in, and here is the sign in page. So now we are going to create a sign in form with a email and password inside it, and then after that we are going to put the Google sign in button. So now let's create the sign in form, get back to the VS Code, and now here within the sign in route, we're going to create another component. I'm going to call it sign in form, then .tsx. Let's create the component here. Let's call the component sign in form, and now here we need to return a form, and then inside the form we're going to create a div, and inside this div we are going to put our two inputs, email and password. So now let me just put some Tailwind CSS classes here. All right, now let's paste the first input. Let's import the label and also the input. All right, and now let's paste the second input, which is for password. So the first one is for email and the second is for the password. And then after that, we are going to paste the submit button, which comes from the components directory. Now let's get back to our page.tsx, and here let's put the sign in form. Right now, let's get back to the browser. You can see we have the sign in page here. Now let's put a forgot password link here after the password input and a sign up link after the sign in button. So let's get back to the VS Code, and here after the password input, let's put the link here. Later we are going to add the reset password functionality to this project, but for now let's just set the href of link to an empty one. And now let's add a sign up button for those who haven't created an account yet. So I just put a div here and a p tag don't have an account, and a link which actually sends the user to the /auth/signup page. All right, now let's get back to the browser. Here we have the forgot password, and here we have the sign up link. All right, now let's get back to the VS Code, and now we are going to create a sign in server action, and then we can use the useFormState and use that sign in server action for handling this form. So let's go to the auth.ts file inside the lib directory, and we have already created a sign up server action. Now in the same way, we are going to create a sign in server action. So here I'm going to export a function. I'm going to call it sign in, and it should be an async one. All right, the first parameter is going to be state, which its type is form state that we have created in the previous section of this video. As you can see, it has an error object inside and a message, and we're going to use the error object for form validation and message for the error messages that comes from the backend API, and we want to show them in our sign in form. Now we need to add the second parameter, which is the form data, and just set its type to form data, and it is going to return a promise which eventually resolve to a form state object. All right, now we can create the body of our project. First we need to do the form validation. So I go to the types file, as you can see, we have already a sign up form schema. We're going to create a sign in form schema. Let's just name it login form schema to avoid confusion between the sign up and sign in. So the object must have an email and a password inside it. And as you can see, the password should have at least one character inside it. All right, let's save this and get back to the auth.ts file. And here, just like the sign up function, we're going to do the form validation. We're going to have a validated field and set it to login form schema dot save parse, and then pass an object, put the name inside it, which comes from the form data parameter that get, then pass the name, and then let's add the password, which again comes from the form data get, and pass the password. If I get back to the sign-in form, we can see the name of the first input is email, and the second one, the name is password. So that's why we get the name and password from the form data. Now we can check the validation here. We're going to say if not validated field.success, we just return a form state object. We're going to set the error object to validated field.error.flatten function, and then put the field errors. And then if the validation field is successful and it actually satisfies the login form schema, we need to send a post request to our backend API. So I'm going to say const response and set it to await fetch API, put the backend URL, and then /auth, and then /sign in. All right, now let's put the config object here, set the method to post, and set the headers, and then set the body to validation fields.data. So we need to use the JSON.stringify and then pass the validated fields.data. So as you can see here, it just has an email and password. That's what we needed in the backend sign-in API. All right, after that, we're going to check if response is okay. We need to get the returning object of the response. So here I'm going to say const result and set it to await response.json function. All right, now here at this point, the authentication with username and password is successful. And here in our Next.js application, we need to create a session and put the user data along with its access token and refresh token that we get in the result object from our backend API in this session. And then in the subsequent request to our backend API, if we want to actually access a protected backend API, we need to include the access token in the header of our request to the backend. Otherwise, we cannot access the protected APIs of our backend API. So this is how the authentication goes in the backend NestJS application. Of course, we haven't implemented that in the NestJS application. We're going to do that in the upcoming section of this video. But for now, let's just test the API. And in the next section, we are going to create our own Next.js session and keep those credentials that we've got from the backend API in a safe place inside this session. But for now, let's just log the returning object from the backend. So just log the result here. And we need to put the else block here after the if block. If the response is not okay, we need to send a message to the sign-in page. So we just need to return a form state object. This time we're going to set the message and we're going to set it conditionally. We're going to check if the response.status code is 401. We're going to set a custom message to the user. We're going to set something like invalid credentials. And otherwise, we just set the message to response.status text. And before we moving forward, here, let me put a to-do comment here, create the session for authenticated user. All right, now let's get back to the sign-in form and let's use the useFormState for handling the form here. So here in the component, I'm going to say const now an empty tuple and set it to useFormState, which comes from the React DOM. And in the first parameter, we must pass the server action. So we're going to pass the sign in function that comes from the lib/auth. And then for the initial state of the form, we just pass the undefined. And now we can get the state of the form in the first element of the tuple. And in the second, we get the action function. All All right. So again, let me remind you that the sign in function that we pass here must have two parameters. The first one is actually the form state, and the second one is the form data, and it should return a promise that resolves to a form state object. In the second parameter of the use form state, we can set the initial form state, and here in the returning tuple, in the first element, we get back the returning object of this sign in server action, and in the second, we just get an action function that, as you can see, takes the form data, so we can set it as the action of the form here. So set the action to just action. So when we submit the form, the action function is running, and it actually runs the sign in server action, and then we get back the state here, and the form is going to be actually re-rendered. So first, let me mark this component with use client because we have used the useFormState, and then we can use the state object here to conditionally shows the validation errors on the form. So first, let me put the error message, if any. So I check the state.message. If there is a message, we can just return a p tag. Let me just go back to the sign up form and copy the whole thing here. Get back here. It just really saves your time and my time, and then get back again to the sign up form and grab the error message on the name input and put it after the name input here, and just put the same snippet after the password. So just use the state.error.password and check if there is a message inside the password. We just render that error message on the password input. So now let's save this and get back to our browser. And actually, I forgot the password of the user that we have created in the previous section. So let's click on the sign up and create a user. Put my name here, all right, and my email. And let me put a password here. Click on the sign up. All right, it's done. And now we've been redirected to the sign in page with the same username and password that we have just created. So I click on the sign in here, and I think there is a problem. So let's get back to the VS Code and let me check the form here. First of all, we need to check for the email input. We need to check the state.error.email and show if there is any error on the email, and it's okay with the password. So let's get back to the sign in function, and here we need to get the email, not the name, and again here get the email from the form. So this is one of the shortcomings of just copy and pasting the code. If you have noticed this error in the first place, please let me know in the comment section below. All right, now let me check here. I think it's done. Let's get back to browser. Let's click on the sign in, and we have an internal server error. It's from the NestJS backend. So let's open up the terminal, and here it says that unknown authentication strategy local. So let's close this off, get back to the NestJS application and go to the Auth module. And yeah, we haven't registered the local strategy in the providers of the Auth module. So let me put the local strategy. All right, let's open up the terminal. Okay, get back to our sign in page and click on the sign in. Again, a internal server error. Get back to VS Code, and here it says that it cannot read the property of undefined reading the local user. So it must be from the local strategy where we call the validate local user. So I get back to local strategy. Here we call this function, and this object is undefined and we cannot read this property. So I think that's it because we haven't used the injectable decorator for the local strategy, and it cannot be managed by the dependency injection container of the NestJS. Let's save this, and the application is running. Now let's sign in again. We don't have any error, so let's go to the VS Code and open up the console of the Next.js application. And yeah, as you can see, we have the result object here. We have the ID of the user and also name of the user as a result from the backend sign-in API. So let's get back to the auth.ts file in the Next.js project, and let me close this one. Okay, as you can see here, we just logged the result object. So it means that the authentication process was successful on the backend side. Now that we have the user data, we need to create a session in the Next.js application or front end, and then keep these user data for managing the authentication in the Next.js side. Alright guys, in this section we are going to create a session management module for our Next.js application. And as I said in the introduction section of this video, we're not going to use Auth for handling authentication in this project. And instead, we're going to use a method for session management that is recommended by Next.js docs. There are some strong reasons behind this. Although Auth is a great option when we want to handle the entire authentication process in our Next.js project, it's not a really good option when we have a standalone backend server and we want to handle the authentication process in that backend server, like the NestJS application that we have in our Monorepo. In Auth, we can update this session in the client components. But in the server component and server side, we cannot easily update the session of the Auth. Although it offers a unstable update session that is for updating the session in the server side, but still it has its own problems. So we cannot easily update this session in the server side in our Next.js application. And this problem really gets bold when we want to handle the Google OAuth authentication in our backend server. And then after the OAuth authentication server is completed and we get the data from our backend server, we cannot easily update the session of the Auth in our API routes. So we cannot actually use the Auth in our use case. And the third reason for not using the Auth is that it offers a complex process for simple use cases. If you don't want to handle the OAuth authentication like Google authentication in your Next.js application, and for example, you want to just use username and password authentication in your Next.js application, in my opinion, it's better to use session management method that Next.js offers in its documentation instead of using Auth for this simple use case. So with these three reasons in mind, we are going to create our own session management module for handling these sessions in our Next.js application. It is more flexible and easier, yet as powerful as Auth in handling the authentication in your Next.js application, especially when it comes to have a standalone backend server. So with these things in mind, now let's go to our Next.js application and creating the session management module. Alright, now let's get back to our Next.js application and I go to the lib directory. Here, I'm going to create a file and I'm going to name it session.ts. In this file, we are going to create and export functions that are required for session management. So first, we need to create a type for our session. Actually, we are going to define the shape of the object that we are going to keep inside the session. So here, I'm going to export a type and I'm going to call it session. All right, it's going to be an object, and inside it, we're going to have a user object. Inside this object, we're going to have an ID, which is going to be string, and a name, which is also a string. After the user object, we also need to keep the access token. It is going to be a JWT that comes from the backend API. So we're going to set its type to a string. And in the same way, we're going to have a refresh token, which is going to be a string as well. All right. Now, when we log in our backend API, it just returns an object that contains ID and name of the user. Later in the upcoming section of this video, you will see we need to create a JWT access token and refresh token based on the data of the user and send them back to the Next.js application. So for now, our backend API doesn't create the access token and refresh token yet. We just comment this to out, and after adding them in the backend API, we will retrieve them here in the session type. So now we need to create a session function, which is actually used for creating a session. So I'm going to say export async function. I'm going to call it create session, and it takes a payload object, which actually is a session object. Right, so the type session is this session that we have defined earlier. Right, now let's create the body of our create session function. First, we need to actually define the expiration time of the session. So here I'm going to say const expired at and set it to a new date object and set it to 7 days from now. So we're going to put the date now and then plus 7 days. So the value must be in milliseconds. So it should be something like 7 times 20 hour times 60 minutes times 60 seconds, then times 1000. This is the 7 days in milliseconds. All right, now we need to encrypt our payload here. here and then keep it inside a HTTP only cookie if we want to keep our session inside a cookie, or we can just set up a database to keep the sessions inside the database. So we're going to choose to keep the session inside a HTTP only cookie, which is only accessible on the server. It means that you cannot access these type of cookies using JavaScript, and therefore is a secure way to keep your sessions. In both way, keeping the session inside a HTTP only cookie or inside a database, you need to encrypt the session. We don't want to save this session plainly, so we need to encrypt this session first. And for encrypting this session, you might say it's okay to use libraries like JSON Web Token and create a JWT from the token using the JSON Web Token library and save the session. Yes, we can create a JWT with JSON Web Token library, but when we are going to retrieve our session in the middleware of the Next.js, it actually won't work. The JSON Web Token package won't work in the edge function and also in the middleware. So we need to encrypt our session using another library called Jose. So I open up the terminal and install the Jose library, npm I Jose or Jose. All right, let's install that. It's done, and now we can encrypt our session using this library. So here I'm going to say const session and set it to await new sign JWT class that comes from the Jose library. All right, and then we need to pass the payload, which we've got from the parameter, and then set the algorithm. So in order to do that, we need to use the set protected handler and pass a config object, and inside it we can define ALG, which stands for algorithm, and set it to HS256. Right, and then we're going to chain another function, set issued at function. It actually embed the creation time of the JWT, and then set expiration time function. Here we need to specify the expiration time in a string format. We can pass the expired at date time that we have created in the previous line, or we can just manually in a string format pass 7D, which stands for 7 days. All right, and as the last chaining function, let's save this to break it into multiple line. We need to call the sign function. And this sign function needs a secret key for creating the JWT. So in order to create a secret key, I'm going to go to the env file and create another variable. I'm going to call it session secret key. And then for creating a secret key, I open up the terminal, and here I'm going to use the OpenSSL to create a random secret key. I'm going to say OpenSSL rand, then dash base 64, and then put the number of bytes here, put 32 for that. And as you can see, it creates a random key. Copy that and paste it here in front of our secret key. All right, so let's close this off and save this. Let's get back here, and now we need to read the secret key from our env file. So outside the function, I'm going to say const secret key and read it from the process.env session secret key, and then put a exclamation mark here to emphasize that this is not going to be undefined. And as you can see now, the type of the secret key is string. And if I try to put it directly inside the sign function here, we've got an error, and that's because in this function we cannot pass a string as a secret key. We need to create a unit 8 array. So in order to do that, we're going to use the text encoder class. So here I'm going to say const encoded key and set it to new text encoder class, and then call the encode function, and then pass the secret key that we've got from the env file. Now we can pass the encoded key here. As you can see, it's a unit 8 array. All right, so the session here is the encrypted version of the payload that we feed to the create session function. Now we need to save the session. As I said, we have two options here. The first one is to save it inside a HTTP only cookie, and the other is to save it inside a database. So we just go for the first option. I'm going to use cookies here. So import the cookies function from the next/header, and then set. The first one needs to be the key. So I just put the session as the key. And then in the second parameter, we pass the payload, which is the encrypted version of the session. And we're going to have a config object. We're going to set HTTP only to true. So as I said, it is really important to set the HTTP only to true because it keeps the cookie only accessible on the server, and actually it is really more secure. Then set the secure to true. Actually, this property secure ensures that the cookie is only sent over the HTTPS connections, actually encrypted connections. Then we're going to have the expire time. So we're going to set the expires to expired at date that we have created in the first line, and then set the same site. It actually controls the cross-site cookie behavior. In other words, it helps protect against cross-site request forgery or CSRF attacks. So you can just set the to strict or lax, but don't set it to none. All right, I set it to lax here, which actually send the cookies on the top level navigation, which means that the cookies are sent with top level navigation, but not with a subsource request. And as I said, just set it to lax or strict. And the last option, we're going to set the path here, which actually determines the URL path for which the cookie is valid. We're going to put a slash here, which means that the cookie is valid for the entire site. It means that the cookie will be sent with any request to the domain, for example, slash anything in our domain. So I just set it to a slash, all right? And that's it for the create session function. It takes a payload object, which its shape is as the session type, and then it encrypts the payload and save it inside a secure HTTP only cookie. All right, now we need to create a get session function for retrieving the session from the HTTP only cookie. So after the create function, we're going to export a new function, async function get session. It actually takes nothing, and inside it, first we need to retrieve the cookie. So here I'm going to say const cookie and use the cookies function of the Next.js, the get and set the key, which is session. So here, as you can see, when we are setting the cookie, we set the key as session. And then when we need to retrieve that, we just need to provide the same key. And then after that, we're going to get the value. So in this way, we can retrieve the cookies in the Next.js. Now, first, we need to check if there is not a cookie with this key. We just return null. All right, now that we have the cookie, it's in a encrypted version. So we need to decrypt the cookie and then return it as the session. So here, I'm going to say const for now an empty object, and then use the JDBT verify function from Jose library. So here I'm going to say await JDBT verify, which comes from the Jose library, and pass the cookie. And then we need to pass the encoded key, which is actually the encoded version of our secret key. Let me flash back here. As you can see, we've got the secret key from the env file and then encoded with the text encoder, right? Let's back here into the get session function. And then as the third parameter, we need to pass the options object. We need to define the algorithm, which needs to be passed as a list, and it is actually HS256. All right, it's done. And now from the returning object, we just get the payload. All right, now we're going to just return the payload, and we're going to cast it as session because we know that its type is as the session type. And actually, we can wrap it inside a try catch block. So if verifying the cookie is failed, it actually throws an error. So we can catch the error here, and we're going to log the error into the console. So I'm going to say console.error and then pass a custom message, for example, failed to verify this session. And I'm going to just pass the error object. All right, now we can, for example, redirect the user to the sign-in page. So it's in the /auth and then /sign-in. We have an error, and that's because we have import the redirect function from a wrong path. So let's import the redirect function from next/navigation. And yeah, we're done for now here. We need to create a delete session function and also an update session function. We use the delete session function for signing out a user. We just delete the session, and we need to update the session when we are going to actually use the Google OAuth authentication. We get the data from the backend, and we need to update the session with that data. All right, so for now, we're done with the session management, and actually we need to mark it with use server to ensure that this is going to be run on the server. And now we can get back to our auth.ts file, and here in the sign-in function, when the response from the backend API is okay, we are going to actually create a session object. So here I'm going to say await create session that comes from the session file, and then here we're going to pass the session object it should have a user object, and then it should have an ID and name. So we're going to set the ID to the result.id. As you can see, the result is a resolved response object from the backend API. And then we need to set the name to just result.name. If I get back to the NestJS application and in the auth service, you can see from the validate local user, we just return an object that has an ID and name inside it. And from the auth controller, we just return that user object. So for now, it's just an ID and name of the user. And later, we're going to add the JWT access token and refresh token to this returning object from the backend. All right, so let's close this and get back to our Next.js application. And in the auth.ts file here, after successful signing into our backend application, we just create a session with those data, and then we need to redirect the user to the home page. So I use the redirect function of the next/navigation to redirect the user to the home page upon a successful login. All right, so let's open the terminal and go to our application and go to the /auth, then /sign in. Let's sign in to our application. As you can see, we have redirected to the home page, and let's open up the console, go to the application, and here inside the cookie, you can see we have a session cookie here. So it means that the authentication process was successful. All right, so we're done with this section, and in the next section of this video, we are going to protect some pages in our Next.js application with the help of the session. Right? We don't have any pages to protect. So now let's quickly create some pages in our application. And then I'm going to show you how you can protect your pages with the session. So get back to VS Code, and here in the app directory, I'm going to create a dashboard page. So first, let me create a dashboard directory, and then inside it, we're going to create a page.tsx. And then create a page component, dashboard, and now we are going to protect this page. But before doing that, let me create an app bar for our application and put the links of the pages in that app bar. So I go to the components directory. I'm going to create a component, call it appbar.tsx. All right, and then create a component here, and then in the JSX, let me put some Tailwind CSS classes, and here I add flexbox to the class name. So now the items are side by side. So let's put some link here. Make sure to import it from the next/link. Set the href. The first one is going to be homepage, so set the caption to home, and the second one is going to be dashboard, and I'm going to set the href to the /dashboard. All right, now let's get back to the root layout of our application, and here before the children, let me render the app bar. Okay, let's get back to the browser. And as you can see here, we have the app bar. Now let's add a sign in and sign out button here on the right side, the app bar. And if the user is already authenticated, we're going to show the name of the user here in the app bar. So let's get back to VS Code. And again, in the components directory, I'm going to create a new components again. I'm going to call it sign in button. Then .tsx, create the component. So here, first we need to mark it with async because we are going to retrieve this session here. And I'm going to say const session and get this session with the get session function that we have created in the session module. It's an async. I use await and call the get session function that comes from the /leap/session. Right now we can check this session if the user is authenticated or not. So in the parent div, let me put some Tailwind CSS classes, flex, item center, and gap2 and ml auto, because we are going to push it all the way to the right of the app bar. Right now inside it, we're going to check this session. We're going to say if session is undefined, which means the user is not authenticated, or we have a session but it doesn't have a user, so put a not before it. It means that the user is not authenticated, so we need to render a sign in and sign up links in this component. So here we're going to use ternary operator, and if the condition is true, we're going to render two link components. So I put a React fragment and then put a link here, set the href to /auth and then /sign in, and the caption is going to be sign in. let's copy that. And the second one is a link to the /auth/signup, and then just put the sign up here. All right. Now, if the user is authenticated, it means that if the session has a value and there is a user inside this session, it means that the user is authenticated, and we're going to render its name on the screen. So again, I put a React fragment here, and we're going to render the name of the user. I use a p tag, and inside it, we're going to render session.user.name. Right, and after that we can render a link for signing out. So again, put a link here and set the href here. We haven't created a wrap for signing out, so just leave it as empty, and we're gonna set the label to sign out. We're gonna add the sign out functionality in the next section, but for now let's just focus on protecting the pages of our application. So if the user is authenticated, we're gonna render this section, and if the user is not authenticated, we're gonna render these two links, sign in and sign up. So let's get back to the app bar, and here let's just put a sign in button component that we have just created. All right, let's get back to the browser. Now, as you can see, we have the name of the user and a sign out button. So you know what, let me just quickly add the sign out functionality. So I'll get back to VS Code and go to the session.ts file. We need to add a delete session function, because when we are going to sign out, we need to delete the session. So just export a new function, async function delete session. Is really easy. It doesn't take anything. And we're going to just call await cookies function, and then use delete function and pass the key, which is session. That's it. Now we need to create an API route in our application and call this delete session in that API route. So when we are going to sign out from the application, we just need to call that API. So inside the apps directory, I'm going to create an APIs directory, and then inside it, we're going to have an auth. Don't confuse it with the auth directory that we have here. It's for the auth pages, and this is for auth API routes. And then inside it, we're going to have a sign out directory, and then inside it, we're going to have our route.ts file, our route handler. So here we just need to export a get function. So let's say export async function get, and then we need to get the request. So just use the rec here and set its type to the next request. Inside it, we just call the delete session function, which comes from the /lib/session, and then we're going to redirect the user to our home page. So I'm going to just return next response, and then call the redirect function, pass a new URL, put a slash here, and the second argument, I'm going to put the rec.next URL. Right, and just in case, we can just revalidate the path, because we are going to flush the cache if the page is cached. So now let's get back to the sign in button, and before doing that, we have a typo here, so let's fix that. It should be sign out. Right, now I get back to the sign in button, and here for the sign out link, we just call the API route /API/auth and then /sign out. It actually calls the get function, and the session will be deleted, and then we will be redirected to the home page. So here, if I click on the sign out, you can see the user is now signed out. We don't have the user here, and instead we have a sign in and sign out buttons. So if I click on the sign in again and submit the form, you can see now again we have the name of the user in the app. So this is the way that we can check if the user is authenticated or not. Now in this section, we are going to protect the dashboard page. We're going to do that in two ways. In the first one, we are going to protect the dashboard page inside the page. And in the second way, we are going to protect the pages in the middleware. So first, now let me show you how I can easily protect the dashboard page inside that page. So I get back to the VS Code and I go to the dashboard page, and here we just need to turn it to an async component, and here we're going to get the session const session and set it to await get session function, and then all we need to do is to check the session object. So I'm going to say if not session, or session does not have a user inside it, not session.user, we just redirect the user to the /auth/sign in page. All right, now let's get back to the browser. First, let me sign out. All right, now let's go to the dashboard page. You can see automatically we are headed into the sign-in page. Again, let's sign in. Now if I go to the dashboard page, you can see we are in the dashboard page because we are signing. It is really easy to protect the pages. So now let's protect the pages with the middleware. So now let me show you how we can protect the pages in the middleware. So first, let me create a profile page inside the app directory. I'm going to create a profile directory, and inside it, we're going to create the page.tsx. Let's create the page. All right, call it profile page. Now we're going to create a middleware. So in the root path of our application, outside of the app directory, let's create the middleware.ts file. Middleware.ts. Now we're going to export the middleware function. So export default async function middleware, and it needs to access to the request object. So I have the rec and set its type to the next request. And then inside it, we just need to check the session. So first we're going to get the session and set it to get session function. Wait, call the get session function. All right. Now we're going to check if not session or not session.user. We're going to just redirect the user to the sign page. So here, just return next response, redirect, and then with a new URL here, pass the /auth, then /sign-in, then second argument, put the rec.next URL, right? Otherwise, we can just call the next response.next function. So here I'm going to say next response.next function, which actually allow to user to access to the page. So if the user is not authenticated here, we call this and redirect the user to the sign-in page. Otherwise, if the user is authenticated, we call the next function, which actually allows the user to access to the protected page. And here we can have a config object, and inside we can determine for which routes in our application we are going to actually enforce this middleware. So I'm going to say export const config, and inside it we're going to have a matcher RI, and here we can define where we are going to enforce the middleware. I'm going to enforce it with the /profile page. As you know, we can also use regular expressions here, and of course we can add multiple routes here. So that's it for middleware. I'm going to test it in a second, and in the upcoming sections of this video, we are going to implement the role-based access control, and we're going to do that in the middleware as well. So we're going to get back here and implement that. And now let's get back to the browser. So we don't have the profile link here. So let's quickly add it inside the app bar. So just copy this link here and set it to /profile and change the caption to just profile. All right, get back to browser and let's sign out first. Okay, now I try to go to the profile page. We are automatically sent to the sign in page. Our middleware is working. Let's sign in. All right, now let's go to the profile and you can see the profile page. So yeah, that's it for protecting the pages inside the middleware. And one thing that we should consider is that when we sign out from our application, we just delete this session, but actually we don't invalidate the user on the backend side. So as you can see in the next section of this video, we are going to create a JWT access token for the user so it can use that access token to have access to the protected APIs in the backend side. And when we sign out from our application in the front end, we need to invalidate that JWT tokens on the backend side. So stay with me in this video. We're going to do that in the upcoming section of this video. All right, now we need to go to our NestJS application, our backend. Now here in the Auth controller, as you can see, when the user sign in into our application, after a successful sign-in, we just return a user object, which actually contains the ID of the user and name of the user. Now we need to create a JWT token and a refresh token and send them back to the client. So the client in the subsequent request to our protected APIs needs to provide the access token inside its header. So in the first place here, we need to create our JWT tokens. In order to do that, we need to install a package called NestJS/JWT. So I open up the terminal and here I'm going to install npm I at NestJS/JWT. And also we need to install the config package in order to be able to access to our env variable. Now let's just install the second package as well, NestJS/config, right? it's done. And let me close this off. And then we can go to the Auth module. And here in the import section, we need to configure the JWT module. So here we're going to add imports list, and inside it, we need to configure the JWT module that register. And then inside it, we need to pass a config object and provide the secret key and also expiration time. But we should keep the secret key inside a safe place like our env file. We should not include the secret key directly in our code base. So as I said, we're going to put it inside the env file. So here I go to the env file, and here I'm going to create a variable. I'm going to call it JWT secret, and we need to create a secret key, and also we're going to create that with OpenSSL. But before doing that, let me just create the second variable. It is going to be JWT expires in, which actually determines the expiry time of a JWT. So we can set it to, for example, 60 seconds. Now we need to create our JWT secret. So I open up the terminal, and here I'm going to use OpenSSL command, and then rand-base 64, and then 32, which determines the number of bytes here. As you can see, it creates a secret key for us. Just copy that and paste it in front of the secret key. All right, let's close this off. And now we can read the env variables JWT secret and expires in from our env file, and then pass it here for registering the JWT module. But in NestJS, we can't use directly process.env and the name of the variable. We need to first install the nestjs/config package, which we have installed earlier, and then we need to register the config package in the root module of our application, our app module. So here in the import section, we're going to use config module, and as you can see, it comes from the nestjs/config, and then call the for-root function, pass a config object, set is global to true. Now we can use the config module in any other module in this application. So now we can use the config module. So let's close the app module, and now here I'm going to create a config file in our Auth module, and then load the values of our env files, and then pass the config file to the JWT module here to register the JWT. So inside the Auth module, let me create a config directory, and then inside it, we're going to have a jwt.config.ts. Right now inside this file, I'm going to export a factory function, which actually creates and returns a config object. So that's why we call it factory function. Here I'm going to export default, and then use the register as function, which comes from the nestjs/config. And here in this function, in the first parameter, we need to specify a namespace. So I'll just call it JWT for the namespace. And for the second argument, we need to create our factory function. As I said, this factory function will create and then return a config object. So the returning type of this factory function should be of type JWT module options. And now we need to write the body of our factory function. It returns an object, and inside it, we need to set the secret. I'm going to read that from process.env.jwt secret. And then we're going to have a sign options. And inside it, we're going to set the expires in option, which we're going to read that from process.env. And then go to the env file and copy this variable, paste it here, right? So the factory function just returns this config object. And now we can use this config object in order to register our JWT module. But when we are going to use the factories function, we're going to call the register async function, and then pass the JWT config, which comes from our config directory, and then jwt.config.ts file, and then call as provider function. So in this way, we can register the JWT module with the config module. Now let's register the config module here, and this time we're going to use for-feature function and just pass the JWT config to it. So now we're done with the config module. It's for creating a config file that actually reads its values from the env file, and then we have registered the JWT module with the JWT config file. So we don't need to provide the secret key and expires in option every time that we are going to create a JWT, which is called the sign function of the JWT. Now I go to the Auth service and then create a login function. So I'm going to say async login, and it takes the user ID, which is going to be a number, and a name of the user, which is going to be a string. And then we put the body of our function, and actually we need to move it inside the Auth service class. Right now, we're going to call this login function in the Auth controller here in the login function, and then pass the user ID and username to that login function, and that login function is responsible for creating the JWT tokens. Now let's create another function here. I'm gonna call it generate tokens. So async generate tokens, and it actually takes the user ID, which is going to be a number, and then we are going to create our JWT tokens based on the user ID that we have here. So we can call this generate tokens inside this login function. So in the first place, we are going to create a payload. So I'm going to say const payload, and then it is going to be an object. It should have a sub inside it, and inside the sub, we're going to just pass the user ID. So in this way, we actually embed the user ID inside our payload, and based on this payload, we are going to create our JWT tokens. But before doing that, let me just create a type for the payload. So later that we are going to decrypt the JWT, we can cast the decrypted value to this type, and we have the autocomplete and type safety. So again, inside the auth module, we're going to create another directory. I'm going to call it types, and then inside it, we're going to create a file. I'm going to name it auth-jwt payload.d.ts. And here we're going to export a type. I'm going to call it auth-jwt payload. There's going to be an object. It should have a property sub inside it, which is going to be number, because we are going to set the user ID to it. If you want to embed the whole user object, we can set the type of the sub here to the shape of your user object. Right, let's save this and get back to our auth service, and here we're gonna set the type of the payload to the auth JWT payload. And now let's create our JWT tokens. We're gonna use a promise.all, so we can simultaneously create the access token and refresh token. So here I'm gonna say const for now an empty array and set it to await promise.all, and then pass a list of promises here. The first one is for creating the access token, so we need to use the JWT service. So here we need to inject that inside the constructor. So I'm going to say private read only JWT service and set its type to JWT service class. Right, now we can use the JWT service here. So here in the first member of the list, I'm going to use this.jwt service.sign async function. It is used for creating a JWT and then pass the payload inside it. All right, for now, let's just create the access token and postpone the creating the refresh token to the next section of this video. So for now, we can just get the access token from the return list of the promise.all. So as you can see, we don't need to pass the sign options for creating the JWT, the secret and expires in, because in the auth module, we have registered the JWT module with our JWT config file, which actually returns the secret and expires in options. So that's why we have used the config module for registering the JWT module. Now let's get back here to our auth service, and then here we can return an object that contains the access token. All right, now inside the login function here, first we're going to get the access token from the generate tokens function. So I'm going to say const an empty object and then call the await this the generate tokens and pass the user ID. And here we can grab the access token. Now we need to return an object actually that contains ID of the user, which is going to be user ID, the name of the user, which is going to be name parameter, and then we're going to have the access token. So as I said, we need to create a refresh token, which we're going to handle that in the next section of this video. So now get back to the auth controller, and here instead of returning the user object, we're going to return this.auth service.login function, and then we need to pass the user ID. So how we can get the user ID from the request object, request.user.id, and then pass the rec.user.name. So if you remember from the previous section of this video, we have the use guard here with the local auth guard. When we send a post request to this sign-in API, it first goes through the local auth guard, and then local auth guard activates the local strategy. It looks for the email and password from the body of the request, extract them, validate them, and if they are valid, it just create a user object which contains the ID and name and append it to the request object, and then send the request to the login API. If the user credentials, email, and password are invalid, we just throw an unauthorized 401 error, right? So that's where this user object that is appended to the rec object is come from. So now let's save this and get back to our Next.js application, our front end, and I go to the lib directory. First, we need to change the type of the session. It should have a access token now, and then I go to the auth.ts file. Inside the sign-in function, as you can see, we have an error on the create session function, and that's because it expects now an access token, which now is come from the result.access token. And this result object actually is the resolved object of our post request to our backend API. So again here, as you can see, the API returns the returning object of the login function, and it returns an object finally that contains ID, name, and access token. And that's why here we have the result.id, result.name, and result.access token. So now let's just get back to our home page. In the app directory, let's just log the session to see if it contains an access token. So first, let me mark this component with async, then get the session const session and call the await get session function and just log the session. Right now, let's run the Monorepo, our Turborepo. First of all, let me see if we have an error in the backend API. All right, now let's open up the front end. Now first, let's sign out because the session is from the previous sign in doesn't have an access token inside it. So let's sign in again. And now let's get back to our VS Code. And as you can see, we have the session object. It has a user ID and name and the access token inside it. So now that we have the access token, we need to create a JWT strategy in our NestJS application, our backend API, and then we can protect our APIs with that JWT access token. Actually, the JWT strategy looks for the header of the incoming request and extract the access token from there, and then validate the access token. If it's a valid access token, it allows the client to access the protected API. So let's do that in the next section of this video. All right, so now let's open up the terminal and we need to install the Passport JWT module. So here I'm going to say npm I passport-JWT. And then we need to install the types of the Passport JWT. So I'm going to say npm I-d at types/passport-JWT. Okay, now let's close this off and go to our NestJS application. And here inside the Auth module and in the strategies directory, I'm going to create a new strategy. I'm going to call it jwt.strategy.ts. And then here in this file, we're going to export a class named JWT strategy, which extends the returning class of the passport strategy. And then here we need to pass the strategy of the passport JWT module. So I just use strategy here. And now as you can see, since we have installed two passport strategy, we have two strategy here under the same name, but these two are imported from different modules. The first one is from the Passport local and the second one is from the Passport JWT. So now make sure that you just grab the passport from the passport-JWT. And then we're going to set the body of the class. And before creating the class, I'm going to mark it with injectable. And then here inside the body of the class, first we need to add the constructor. And inside the constructor, we are going to call the superclass. And then inside the superclass, we need to pass an option object. And here we need to set some options. But if I open the autocomplete here, you can see we don't have any autocomplete for the options here. So in order to get access to the options, let's create a dummy instance of the Passport JWT class here. I'm going to call it just test and set it to new strategy, which actually comes from the Passport JWT. And then we're going to pass an option object. And here, if I hit the control space, we have access to the options. So we need to set the JWT for request, and the other one is secret or key. I'm going to explain them what they are star, and then ignore expiration. All right, so let's just copy the object here and paste it here in the super function, and then we can just remove this dummy instance from there. So now the first option is JWT from request. It actually determines where this strategy should actually look for the JWT of the request. In order to set that, we're going to use extract JWT, which comes from the passport JWT. And then as you can see, we have some options here. We're going to choose the from auth header as bearer token. So actually in this strategy, we're looking for a JWT access token inside the auth header of the request as a bearer token. I will show you how you can set the access token in the auth header of the request in the Next.js section of this video. But for now, we need to set secret or key. And here we need to pass the same secret key that we have used in order to create a JWT. So if I go to the auth module, you can see we registered the JWT module with the JWT config file. And if I go to the JWT config file, you can see we're going to export an object that has a secret. And this secret comes from the JWT secret env variable. So now we need to pass this secret, which is the same secret we have used for creating the JWT, to the secret or key in the super function of the JWT strategy. It actually uses this secret in order to decrypt the JWT. So we need to use the JWT config, and in order to do that, we need to inject that inside this class. So here in the constructor, I use @inject. Then we need to provide a key. So I use the JWT config dot key. It provides a key for us, and then we're going to have a private JWT configuration. The name is actually up to you, and then we need to set its type to config type. And then in the generic, pass the type of the JWT config. All right. Now we can use this JWT configuration, which actually return the JWT config. So here I'm going to say JWT configuration dot secret, and then here we just set ignore expiration to false. If we set it to true, it actually allow the user to access our protected API with a expired JWT, and we don't want to do that. So we'll just set the ignore expiration to false. So now outside the constructor, we need to implement the validate function, and the validate function takes a payload. So what is the payload? When a request comes through a API which is protected by JWT strategy guard, it actually activates the JWT strategy, and it looks for the JWT inside the auth header as a bearer token. It extracts it, and then with this secret key that we feed to the JWT strategy, it will decrypt the JWT and verify the JWT. If the JWT is valid, it is going to call the validate function and feed it with the payload object, which is actually the decrypted version of the JWT. So it actually decrypt the JWT and then extract the payload from it, and then pass the payload to the validate function. So here we need to set the type of the payload to the auth JWT payload, and here let's import it as a type, and then here we need to extract the user ID from the payload. So I'm going to say const user ID and then set it to payload.sub. So as you remember in the Auth service and the generate token function, you can see that we set the user ID to the sub, and now here we just extract the user ID from the sub again. All right, now we have the user ID, we need to validate the user. That's why we call this function validate. So I go to the Auth service, and here we're going to create a function called validate JWT user. So I'm going to say async validate JWT user. It takes the user ID, which is going to be a number, and then inside it, first we are going to retrieve the user from our database based on this user ID. So I'm going to say const user and set it to this user service find one. So we don't have the find one. So let's just go to the user service and create the find one function. Here, just go to the user service. Actually, let's just copy this function, which is find by email. Just call it find one and take the user ID, which is going to be a number. All right. And then find unique. We just set the ID as user ID. All right, so we actually find the user based on its ID. Now get back to our auth service and call the find one, pass the user ID inside it. So now we're going to check if the user is in the database or not with this user ID. I'm going to say if user is null, which means that the user is not found with this user ID. We're just going to throw an unauthorized exception. So I'm going to say throw new unauthorized exception. Then as the message, we're going to say user not found. So why are we doing this? For example, in a situation, a user logging into our application and get its access token. And for some reason, the user is deleted from our system. For example, the admin delete that user, but the user can access to our protected APIs with that access token that it's retrieved from the sign-in API. So we need to check that the user is inside our database. If that's not the case, we'll just throw an unauthorized exception. And if the user exists, we just allow the user to access that API. So here we need to return an object from this JWT user. I'm going to say const current user and set it to an object that has the ID, and I'm going to set that ID to the user.id. So here we forgot to use the await here before this function. Make sure to use that. It is really important. If you don't use await, this function will return a promise and the user is actually not a user. It will be a promise. And then when we check if the user is not null, this condition is always a true value because it's a promise. It's not undefined. So if we wait for that to be resolved, we get the user object, and if the user was not found, we've got the user as undefined or null. So now we can remove this await here from the user, and then we can just return that current user object from this function. So now if I get back to our JWT strategy, we need to call this function that we've just created. So we just return this .auth service. So we don't have the auth service here, so we just inject it to this class real quick, private auth service, and set its type to the auth service class. All right, now here we can use the auth service, this .auth service actually, and call the validate JWT user and pass the user ID inside it. Okay, so this function will return an object that contains the ID of the user, and then we're going to return that object from this validate function. And just like the local strategy, the returning object of the validate function will be appended to the request object under the property user. All right, so we're done with the validate function, and now we need to create a JWT auth guard. So I open up the terminal and I'm going to go to the apps and then API directory where the NestJS application resides. So let's clear this up. And then here I'm going to use nest for creating the guard, nestGU. It is going to be inside the auth and then guards directory, and then its name is going to be JWT-auth. Now let's close this off and go to the guards directory. We have the JWT auth directory, and inside it we have the JWT auth guard.ts. Now, just like the local auth guard, we don't want this section. JWT auth guard just needs to extend the auth guard function, actually the returning class of the auth guard, and pass the JWT into the auth guard and then put the body of the class. That's it. Now we need to get to the auth module and register the JWT strategy. Right now we can protect our APIs using the JWT auth guard. So let's go to the auth controller. Now let's create a get endpoint and actually call it protected, and then create a function for it. For example, get all. It's just a dummy function, and then inside it we're actually going to return just a message, and we're going to say something like, now you can access this protected API. And let's just import the get from NestJS/common, and now we can mark it with the use guards and pass the JWT auth guard. So when the client send a request to this endpoint, first it goes through the JWT auth guard, and the JWT auth guard will activate the JWT strategy, and the JWT strategy under the hood looks for the JWT token inside the author there as a bearer token. It decrypts the JWT token with this key that we fed to it, and then verify that. If that's a valid JWT, it actually extract the payload out of it and then pass the decrypted payload to the validate function. And inside the validate function, we're going to grab the user ID from the payload and then validate the JWT user. If that's a valid user, we're going to just return an object that contains the ID of the user inside it, and that object will be appended to the request object under the property user. So for example, let's go to the auth controller. Here we can access to the request object, and here for example, let's turn into a backtext, and I'm going to say this is your user ID, and then put the rec.user.id. So in this way, we can protect our APIs with JWT. In the next section of this video, we are going to send a request from our front-end application, our Next.js, to this protected API and actually test this API to see if it is protected or not. So let's do that. All right, so now let's go to the Next.js application, and I go to the profile page, and here we are going to send a request to our protected API. In order to do that, I prefer to create a actions file. So here in the lib directory, I'm going to create a file and name it actions.ts. And here we are going to create a server action. So first we need to mark it with useServer directive. And now we are going to create a function in which we're going to send a request to our backend protected API. So here I'm going to say const, for example, let's call it get profile and set it to an async function. And inside it, we are going to call the protected API. So first we need to get the session and extract the access token out of it. So I'm going to say const session equals to await get session. All right. And now we're going to use fetch API to send a request to our protected backend API. So I'm going to say const response and use await, use fetch API, put the background address. Let me zoom in, and here put the backend URL, and then call the auth, and then I think it was protected. Yeah, protected. Get back here and call the protected API. Let's put the configure object here. And in order to include the access token, we're going to do this. Inside the headers object of our request, we are going to put a authorization key. So pay attention to the spelling, and we're going to set it to a string, and it should start with bearer word. So put bearer and then a space, and then we need to put our access token. So I'm going to get it from the session.access token. And that's it. We include the access token in the auth header of our request as a bearer token. Add the authorization key in the headers and set it to a text which start with a bearer word, a blank space, and then put your access token. The JWT strategy of our Next.js backend API will extract that from the header of the request. All right. And then we're going to just get the result. So I'm going to say result equals to await response.json. Okay. And then just return the result. I get back to our profile page. And first of all, let's turn it to an async component. And here I'm going to say const res, for example, and call the await get profile function that we have just created. I think I didn't export that from the actions file, so let's just export it. All right. And now here inside the profile page, let's put a p tag and then just actually use JSON.stringify and put the res inside it. So just render the result in our page. So now let's get back to our browser. First of all, let's sign out, then let's sign in again. All right. Now let's go to the profile page, and we have an unexpected error. It says it's not a valid JSON. And I think that's it, because in the auth controller of our backend API, we just return a string as the result. And then in the profile page, when we are going to use it with JSON.stringify function, it gives us the error. So let's wrap it inside an object here. And for example, let's set the message to a message property. All right. Now let's get back to our browser, refresh the profile page, and we don't have anything inside our page. So let's get back to the VS Code and get to the get profile. So that's because we didn't put the return here. Let's get back to our browser and go to the profile page. You can see now we have the message that says, now you can access this protected API. This is your ID, which is the ID of the user. Now let's get back to the VS Code, and here let's just comment out the authorization section so we don't include the access token in the header of our request. Now, as soon as I get to the profile page, you can see we have an unauthorized message from backend API, and that's because we haven't included the access token in the header of our request. So let's get back and fix that. All right, let's put him back in and get back here, refresh the page. We still get an unauthorized error. That's because we set the expires in time of our backend JWT to just 60 seconds. And this is very important to not confuse the expire time of your session in the Next.js, which we have set it to 7 days, and the expiry time of the JWT access token that we create inside our backend project, our NestJS project. We just set them to 60 seconds. So even we stay signed in our front-end application, our Next.js, we actually signed out from our NestJS application. We're not authenticated user in the backend server because our JWTs are just valid for 60 seconds. So let's get back to the NestJS application and go back to our auth service here. And actually, let's go to the env file where we have the JWT expires in. As you can see, it's 60 seconds. We can actually change it here and sync it with the expiry time of our session in the Next.js. But we are going to add another functionality to our backend server, which is refresh token. So when the user has a expired access token, it can refresh its token and renew it actually with the refresh token functionality in our NestJS application. So we just let it to be just 60 seconds and we get back to our browser. We're going to sign out from our application, sign in again. Now we've got a new refresh token when we signed in. If I get to the profile page, you can see we have the result from our backend protected API. All right, now we are going to add refresh token functionality in our NestJS application. All right, now let's go and add refresh token functionality in our application. So I go back to the NestJS project, and here we are in the env file of our NestJS application. So here, as you can see, we have the JWT secret and JWT expires in. But we don't want to use these two options for creating the refresh token. We are going to create another secret and expires in for the refresh token. So here I'm going to say refresh JWT secret and refresh JWT expires in. All right. So we're going to set the expires in of the refresh to 7 days. And for the secret key, just open up my terminal and let's create a secret key with OpenSSL command, OpenSSL rand -base 64 and then 32 for the number of bytes. Okay, let's copy that and paste it here for the refresh JWT strategy. Now in the next step, we need to create a config file for our refresh token. So here inside the config directory of our auth module, we're going to create a new file. I'm going to call it refresh.config.ts. And here I'm going to export default a factor function, but let me just register it with the register as function. It comes from the NestJS/config, and we need to pass a namespace. So it's really important to have a different namespace for the refresh token. As you can see here in the JWT config, we set it to JWT. So let's set it to refresh-JWT for the refresh config. If you just set it to the same key as the JWT, when you are going to inject it in your module, for example, let me open up the JWT strategy. Here, as you can see, we use the key of the JWT config to inject it inside the strategy. If you use the same key for your refresh JWT, when you are going to inject it in other classes, it actually inject the JWT config instead of the refresh config. So make sure to have different namespace here for your config file. And then let's get back here. In the second parameter, we need to pass a factory function. It should return object, and let me type the returning value of the object. If I get back to the JWT, you can see the returning type is JWT module options, but here we need to have a different type. It should be JWT sign option. All right, so we use the JWT module option when we are going to actually register the JWT module. So as you can see here, we have the JWT config module, but when we are going to use that config file for signing a JWT, we should use the type JWT sign option. It is not really different. We have the secret here, just like the JWT config, and it is going to be from the process.env and then .refresh JWT secret. And then this is the difference. We have expires in directly on the main object, and we're going to set it to refresh JWT expires in. That's it. And let me get back to the JWT. You can see the expires in the JWT module options type should be inside a child object sign option, but here with JWT sign options, we just put it directly in our main object. That's the difference. So let's save this, and now with this config file, we can create our refresh token. So I get back to the auth service, and here in the generate token, now we can create our refresh token. So here inside the promise.all function, we're going to create another promise for creating the refresh token. So I'm going to say this.jwt service.sign async, pass the payload. And if we don't pass any config file, it just use the default config file, which is for creating the JWT access token. But we want to use the config of the refresh token. So here we need to pass the refresh token config file. So I go to the constructor and inject the refresh token config file that we have just created. So I use as inject and then pass the refresh token config. As you can see, it comes from the config/refresh config file that we have just created. Pass the key. This is actually the namespace that we have specified in the first parameter of the register as function on this file. Now we can have refresh token config. The name is really up to you, and the type should be of type config type, and in the generic we should use type of refresh config. Right now we need to just import the inject decorator from the nestjs/common and get back here in the generate token function. And for the second promise here, we just use the this.refresh, so we don't have it. Get back to constructor, or we should have a private before the refresh token config in the constructor. Now we can have access to it. All right, so we just pass the refresh token config that we have created in the refresh token file. Use different secret and different expires in. Get back to our auth service and in the generate tokens, and now we need to get the refresh token in the second member of the returning tuple of the promise.all function. I'm going to call it refresh token and then return it here inside the returning object refresh token. Now in the login function where we call the generate tokens function, we should extract the refresh token and put it here in the returning object. So let's get back to our auth controller. As you can see, upon the successful sign-in, we call the login function, which actually calls the generate token. And I think we have misspelled the refresh token here. So let's fix that. So we get the access token and refresh token from this function and return them in the returning object. And in the auth controller, we just return them back to user. All right. Now we need to get back to our Next.js application, our front end, and go to the auth.ts file. Inside the sign-in function, when we are going to create a session, we need to include the refresh token in our session object. So I use refresh token and set it to result, which is result of our post request to our sign-in API, and then refresh token. As you can see, we have an error here, and that's because the refresh token is not in the type of our session. So I get back to the session.ts file and just uncomment the refresh token from the session type. Get back to the auth.ts. As you can see, the error gone. So now upon the sign-in request to our backend API, we get the result object, we create our session with the user object, and we set the access token as well as the refresh token here. So let's go to our dashboard page, and here let me log the session to see if we get the refresh token inside the session. So I just log it and get back to our browser. We have a fetch failed error, so let's get back to our VS Code, open up the terminal, and here we have an error on our backend API. We need to register the refresh token config in our auth module. So let's get back to our Next.js application, and here in the auth module, we just copy this line, config module.forFeature, and pass the refresh config. Let's open up the terminal, and as you can see, the error is gone and the server is running. So let's get back to our browser. Let's refresh the page. Let's sign in our application, and let's go to the dashboard. All right, let's open up the terminal, and here, as you can see, we have the session object, we have the access token, but we don't have the refresh token. So let's get back to our Next.js application. I go to the auth service, we have the refresh token. All right, so let's just copy that. It might be from the spelling, and get back to our auth.ts in the sign-in function. Let's just put it here on the refresh token, and yeah, as you can see, we just missed a H in the refresh token. So let's fix that. All right, and get back to our browser. First, we need to sign out and sign in again. All right, now let's go to the dashboard, get back to our VS Code, and open up the terminal. And as you can see, we have the session object and we have the refresh token. All right, so this is working without an error. So now we generated the refresh token. Now we need to get get back to our NestJS application, our backend, and create a refresh token strategy and also a refresh token API. So when the user has a expired JWT access token, it can actually send a request to the refresh token and refresh its access token. Alright, before getting started, let me show you the whole process of refreshing the token in a diagram here. So suppose that the access token of the user is expired, and in the front end, we are going to refresh our token. So we need to send a post request to the refresh API in this /auth/refresh, and the refresh token API is guarded with the refresh auth guard. So this request, before going to the refresh API, will actually go through the refresh auth guard and it activate the refresh strategy. And in the refresh strategy, we check the request and, for example, looks for the body of the request or header of the request to see if there is a refresh token included. We extract the refresh token from the request and we validate that refresh token. If it's valid, we are going to validate the user just like the JWT strategy. And if it's okay, we are going to append the user object to the request object, and then we are going to allow the user to access the refresh token API. And inside the refresh token API, we just call the login function, which actually creates a new access token as well as the new refresh token. So yeah, this is the process. We need to create a refresh token API, a refresh strategy, and also a refresh auth guard. So for now, in the first step, let me create the refresh strategy. Get back to VS Code, and here in the strategies, I'm going to create a new file. I'm going to call it refresh-token.strategy.ts. And this strategy is much like the JWT strategy. So we can just copy that here. I just copied whole the JWT strategy and paste it here. So as you can see, we use the strategy that is come from the Passport JWT. So we don't need to install a new strategy from the Passport. We just use the Passport JWT strategy for this refresh strategy. So now we need to make a little change to this strategy. First of all, we need to pass a name for our strategy. So here I use refresh-JWT. All right. The default name of the Passport JWT strategy is just JWT, but we are going to change that to refresh JWT. So when we are going to create our refresh auth guard, we just need to pass the refresh JWT instead of the JWT. Okay. So this is the first change. And then here we need to use the config of the refresh token. So in injecting our refresh token strategy, we're going to use refresh config, and then let's call it refresh token config. Okay, and set its type to the config type and use the type of the refresh config. Now here, as you can see in the super function, we need to specify where we are going to look for the refresh token. We just go the same as the JWT. We are expecting the refresh token to be inside a authorization key as a bearer token in the auth header. We can also change it to, for example, from a body field and pass the name of the field. For example, set it to refresh. So now our request for refresh token should have a refresh field inside its body. So for this time, let me try this method. And here, as the secret key, we pass the refresh token config.secret. This is different from the secret that we have created the JWT access token. We are setting the refresh token secret key because we created the refresh token with this secret key. So we need to provide the same key for decrypt that. All right. And also ignore the expression just to false, the same as our JWT. And here in the validate function, we have the payload, which is actually the decrypted version of our refresh JWT. We are going to extract the user ID from this payload object. And then here we need to create a validate refresh token. So let me just change it to validate refresh token. And let's just declare this function inside our auth service and go to the auth service. And here, let me cut that and paste it here at the end of our class, our auth service class. And here we just want to validate the user. So I just copied this section and paste it here. So as you can see, it is the same as the validate JWT user, but later in this video, we are going to add a functionality for revoking our refresh token. So when the user is signed out from our application, we need to revoke the tokens of the user. That's why we have created a separate function for validating the refresh token. For now, it is the same as our validate JDB to user, but as I said later in this video, we are going to add the functionality for revoking the token of the user. So we need to actually validate the refresh token of the user here to see if the user has already signed out or not. All right. But since we haven't implemented that functionality in our application, first we just let it as it is. We just retrieve the user from our database based on the user ID that we have extracted from our old refresh token, and check if the user is null. We just send a unauthorized exception to the client, and if the user is found, we just create a current user object with a user ID and return it from this function. All right, so let me put a curly braces here, and we need to mark this function as async. All right, and now we are going back to our refresh token strategy. As you can see, we call this function and returning that current user object from the validate function. And as you know, this object that is returning from the validate function will be appended to the request object under the property user. So it is something like this, request.user. So we're done with the refresh token strategy, and now we need to create a refresh auth card. So I open up the terminal and I go to the NestJS application in the terminal, apps.api, and now we can use the nest CLI, nestGGU, for generating a new guard. It should be inside the auth module, and then guards directory, and it should be refresh-auth. So it will create a refresh-auth directory inside the guards directory, and we have the refresh auth guard. So we don't want this section. It should be a class that just extends the returning class of the auth guard function, which comes from the nestjs/passport, and we need to pass the name of our strategy. It should be refresh-jdbt. So that's why we have changed the default name of our refresh strategy here in the first line of defining our strategy. And as you know, we just forgot to rename this class. Let's rename it to refresh strategy, and we have this name. So get back to our refresh auth guard. We have a refresh auth guard that just extend the returning class of the auth guard and pass the name of the strategy, which is refresh-jdbt. Now, as a last step, we need to register that in our auth module. So inside the provider section, we just added refresh strategy. Okay, and now let's get back to our diagram. We have created the refresh strategy and refresh auth guard. Now we need to create our refresh token API. So let's get back to our VS Code and I go to the auth controller. Let's create a refresh API. So it should be a post request and set its route to just refresh. Okay, and let's have a function for it. I'm gonna call it refresh token. Okay, put the body of the function and let's guard it with use guards and pass the refresh auth guard. All right, now that we have guarded with refresh auth guard, we expect that request object has a user ID. So just use request the creator here for accessing the request object. I'm gonna call rec, and now here we need to actually generate new refresh token and access token and send it back to user. So I get back to the auth service and I'm going to create a new function for generating new access token and refresh token. It is going to be an async refresh token. It takes the user ID, which is going to be a number, and first we are going to call the generate token function. It is much like the login function. So let's go to the login function. Here I can just copy this and paste it here. We just need to have a name, which is going to be a string. And now, as you can see, it just create the generate token. But here you might ask why we have create a separate function. We can just use the login function because it is exactly the same as the login function. And the answer is that later in this video, we are going to add a revoke token functionality in this project. And then after that, we need to make some changes to this function, which is called refresh token rotation, that is needed for revoke functionality for this project. Stay with me until this video and you find out how we can do that. All right, so now let's get back to our auth controller and then just return the refresh token function from the auth service. So here I just return this auth service refresh token function and pass the rec.user.id and also rec.user.name. All right, that's it for the refresh token API in the backend section. And now we need to get back to our Next.js application, our front end, and use this functionality. All right, now in this section, we are going to use the refresh token API from our Next.js application, our front end, to refresh the expired token of the user. First, we are going to create a refresh token function, which actually sends a request to the refresh token API and get a new access token and refresh token. And then we are going to create a custom fetch API in our Next.js application so we can automatically check if the access token of the user is expired. We just send a request to the refresh token API in the backend side and renew our access token and refresh token, update the session, and outside the custom fetch function, we just need to call our protected API. We don't want to worry about if the access token is expired or not. We just do it automatically in the custom fetch API. So in the first step, we need to create our refresh token function. All right, so I go back to the Next.js application, and here in the auth.ts file, we are going to create a refresh token function. So I'm going to export a refresh token function, refresh token, and set it to an async function. It takes the old refresh token, so I just call it old refresh token, which is going to be a string. And then let's write the body of the refresh token function. Let's use a try catch block here, and let's put the catch. All right, now inside the try section, we are going to send a request to the backend API. I'm going to say const response and set it to await fetch and put the backend URL and then /auth and then /refresh, which is actually the address of our refresh token API. All right, now let's put the configuration function, and here we're going to set the method to post. All right, and inside the body, we need to put a refresh token. So if I get back to our Nest.js application and go to the refresh token strategy, we expect the refresh token to be inside a body field under the name refresh. So get back to our refresh token in the Next.js. Here, we're going to set the body to JSON.stringify and pass an object. Inside it, we should have a refresh and set that refresh to the old refresh token that we have here in the parameters. All right, so that's it for our request to the backend API. And now we can check if the response is not okay. Response.okay actually is not okay. We just throw a new error, which is going to be something like failed to refresh token. All right, otherwise we can just take the access token and refresh token out of the response object. So here I'm going to say const and put an object here, and then we're going to call the response.json function. All right, now we can grab the access token and also refresh token from the response object. And now here we need to update our session to set the new access token and replace the new access token and refresh token with the old ones. So for updating the tokens, I'm going to go ahead to the session.ts file and create a update token function. So I'm going to export an async function and name it update tokens. And in the parameter, I'm going to take the access token and refresh token. So I create an inline type for the parameter. It is going to be an object that has access token, which is going to be a string, and also a refresh token, which is going to be a string as well. All right, now we can grab the access token and refresh token from the parameter object. Now inside the body of the function, first we need to get the session. So I'm going to get the session from the cookies. So I'm going to say const cookie and set it to cookies function .get and put the session as the key and then set the value. All right, now we're going to check if the cookie is null. So if not cookie, we just return null. Then we are going to actually extract the payload. So I'm going to say const for now an empty object and set it to await and JWT verify. And actually we can type the returning object to the session type and pass the cookie and also the encoded key that we have here in the beginning of the file. It's actually the encoded version of the secret key which comes from the env file. Get back to our update token function. After using the JWT verify, we can grab the payload from the returning object, and here we can check if not payload, or if the payload is undefined, just throw a new error and, for example, say session not found. All right, now we can create a new payload. So I'm going to say const new payload and set its type to the session type. All right, and here we're going to specify the user, set it to an object, and we're going to just spread the payload user. All right, and then put the access token and refresh token that we have from the parameters of this function. All right, after creating a new payload, we can just call the create session function. So here I'm going to call the create session function and pass the new payload. So it actually replace the session cookie with this new payload that actually has new access token and new refresh token. All right, so let's just save this and get back to the auth.ts file, and in the refresh token function here, let me just comment that we need to update the session with new tokens. Okay, just call the update token function that we have just created, but it actually has some problem. So let's just use that wait update tokens and pass the access token and refresh token. I will show you what is the problem with this function with using the update token function here, and I'm going to just come up with a solution to solve that problem. All right, so for now I just use the update tokens here, and after updating the token we need to return the new access token from this function. And here the catch block, I'm going to just get the error, and first of all let's console.error the error. First I'm going to say refresh token failed and then pass the error object, and finally we just return null from this function. All right, so we have the refresh token function. And now we need to create a custom fetch function which checks if the access token is expired, calls the refresh token inside it, and get a new access token. So in order to do that, let's create a file. I'm going to call it authfetch.ts, and inside it we're going to create a function, export const, I'm going to call it authfetch and set it to an async function, and then let's put the body of the function. So this auth function actually serves as a wrapper function for the default fetch API, and then use fetch function to send a fetch request to the protected backend APIs. So it automatically get the access token from the session and then call the fetch function to send a request to our backend's protected API. And if the access token is expired, we're going to call the refresh token function, get a new access token, and send again the original fetch function with the new access token. So if I use the fetch here, you can see it takes two parameters. The first one is actually the URL of the API, and the second one is the options, which its type is request unit. So we need to have the same parameter in the auth fetch. I'm going to call the first one URL and set its type to string or URL, and then we're going to have the options and just set its type to request init. All right, so inside this function we're going to set a fetch request to this URL with these options. So it's going to be something like this: response equals to await fetch, pass the URL and the options. But before running the fetch, we need to get the session, and from the session get the access token and include the access token inside the header section of the options object. So first let me get the session, const session equals to await get session. All right, and now we need to include the access token from the session to the options.header. So I'm going to say options.headers equals to an object and spread the previous options. So here I'm going to say options.headers. All right, and then create an authorization key and set it to a text. It should start with bearer and a blank space, and then put the access token. So use the session.access token. And here we need to make the options object optional, because sometimes we don't want to pass the options object. But we've got an error here, and in order to fix that, instead of using the question mark here, we just need to set the default value of the options object to an empty object. For now, this do the trick for us, but it still has a problem, and I will show you what is the problem and also what is the solution. So as you can see, up to this point, we get this session and include the authorization inside the headers of the options, and then send a fetch request to the specified URL here with the provided options. So now we need to check if the status of the response is 401, which is a unauthorized exception from the backend side. This means that our access token is not valid. So we try to get a new access token with our refresh token. So first we need to check if the response.status equals to 401. We're going to call the refresh token function to get a new access token. So first we need to check if the session has a refresh token inside it. I'm going to say if not session.refresh token, just throw new error and say something like refresh token not found. Otherwise, if we have the refresh token inside this session, we're going to just call the refresh token function. So here I'm going to say const new access token and set it to await refresh token function and pass the session.refresh token. All right, here we're going to check if we have a new access token. If it's not null, we're going to replace it inside the options.headers object. So here I'm going to say options.headers.authorization and set it to, let me just take this one and paste it here. And instead of the session.access token, we just put the new access token. So as you can see, we have an error here, and that's because our options object might be a empty object and it doesn't have the headers inside it. So we can't access to the authorization header. So in order to fix that, we need to create custom options type. So here I'm going to export an interface and name it fetch options. It should extend the request in it. So put it here, and inside it, we're going to have a headers object. It should be optional, and we're going to set its type to a record type and specify the type of the key, which is string, and the type of the values is also string. All right, now we need to set the type of the options type to the fetch options. And if I get here, you can see the error is gone. So that was the problem, and this is the solution for that. Get back here, and after replacing the new access token in the headers object, we are going to send the original fetch API with no access token. So here I'm going to say response equals to wait fetch our URL and pass the options, which now has the new access token inside. And finally, we just return the response. Right? So as you can see, we have created a wrapper function for the basic fetch API, which automatically get the access token from the session. And if the access token is expired, it calls the refresh token function and get a new access token. Also inside the refresh token, we update the tokens inside this session and then send the original request with the new access token here, and then just return the response. So now let's save this and test this auth fetch function here. So for testing, I go to the profile page, and here, as you can see, we call the get profile function, and inside it, we send a request to our protected API in the backend side. So now, instead of using this fetch function, we're going to just use the auth fetch. So I'm going to say const response and set it to await auth fetch. Just pass this URL here. So let's grab it here, paste it here, and we don't need to provide the access token here. It is automatically retrieved from the session in the auth fetch function. All right, so let's get back to browser. And as you can see, we're signed in, but our access token is valid for just 60 seconds. And now obviously it is expired. So let's go to the profile page. And as you can see, we just get the unauthorized message from the backend side. And actually the refresh token functionality here doesn't work. So let's get back to the VS Code and open up the terminal and show you the problem. So as you can see here, we have an error, refresh token failed, which says that the cookies can only be modified in a server action or a route handler. So that's it, because here inside the refresh token function, we want to update the tokens directly here inside our function, and that caused the error. As I said, we need to update the session inside a server action or a route handler. So you might say that, well, this is a server action. Yeah, this is a server action because we marked the entire file with the userver, but the actual server action needs to be called from a client component form, just like the sign-in API that we have here. As you can see, we create the session inside the sign-in function, but the sign-in function is called from a client-side form. But in this case, we are going to modifying the cookies from a server component, and that caused the problem here. Here, if I go to the profile page, you can see it's a server component which calls a get profile, and inside the get profile we call the auth fetch, and in the auth fetch we call the refresh token, which finally calls the update token function to modify the cookies. As I said, the origin of this call stack was from a server component. So in order to fix that, we are going to call these update tokens inside a API route handler. And then here, instead of directly calling the update token function, we're going to send a request to that API route handler. So in order to do that, we go to the APIs directory, and in the auth directory, I'm going to create a new directory, call it update, and inside it, we're going to create our route.ts file. So now we are going to export a post function, export async function post, get the request object here in the parameters, set it to next request, and then here inside the function, we expect the access token and refresh token from the body of the incoming post request. So now let's get the body. I'm going to say const body equals to await rec.json, and now we're going to get the access token and refresh token out of the body object. So here I'm going to use the structuring pattern, set it to body. All right, now get the access token and refresh token out of it. Now we're going to check if there is not a access token or refresh token inside it, we just return an error. So I'm going to say if not access token or not refresh token, we're going to return a new response, and inside it we're going to say provide tokens and set the status code to something like 401. All right, and otherwise, if the access token and refresh token are inside the body object, we're going to just call the update token function. So we need to pass the access token and refresh token to it, and then after that we just return a response, but this time okay, and set the status code. We forgot to put the new before it. All right, now we can access to the status and set it to 200. All right, so that's it for the update API in our front end. We expect the access token, refresh token to be inside the body, and then call the update function with our access token and refresh token. Now let's get back to our refresh token function, and here, instead of directly calling the update tokens, we're going to just send a post request to it. So here I'm going to say const update res and set it to await fetch and pass the address of our update API. It is going to be HTTP localhost 3000, which is the address of our Next.js dev server, then API auth, and then update. All right, so if we in the production environment, make sure to replace this address with the production web address of your Next.js server. Okay, and in the option object, we need to set the method to post and then set the body to an object that contains the access token and refresh token. So we're going to use the JSON.stringify here and pass an object with the access token and refresh token inside it. All right, now we need to check if the request is not okay, we just throw an error. So here I'm going to say if not update res.okay, we need to throw an error, throw new error, and say something like this: failed to update the tokens. All right, the rest of the refresh token should be the same. So let's save this, and now let's get back to our browser and refresh the page. As you can see now, this time we can access to our protected backend API, which means that our refresh token mechanism is working properly. So yeah, that's it for the refresh token mechanism inside our front end Next.js. Let me do a quick recap here. We have created a refresh token function which sent a request to our backend API for refreshing the token. It gets the new tokens and call the Next.js update token API, which actually replaced the session with a new session with the new access token and refresh token, and then returns the new access token out of the refresh token function. Then we have created a auth fetch, which is a wrapper function for the basic fetch API. Inside it, we get the session and put the access token in the auth headers of the options object and send the fetch request to the specified URL with the options object that now has the access token inside it. All right. If the response returns back with an unauthorized error code, we actually call the refresh token function, get the new access token and refresh token, update them inside the session and grab the new access token here. And now we need to replace the new access token with the old one inside the auth header of the options object and then pass the original fetch API with the specified URL and options object, which now has the new access token inside it. And finally, we just return the response. So in this way, we automatically use the refresh token API, which our backend API exposes in the Next.js application. And if you're still here so far with me, I'm pretty sure that you liked this video and this video was helpful for you. So please hit that like button in order to give me energy to move to the next section of this video. Thanks for your support. And now it's time to integrate Google Authentication in our Monorepo. We are going to handle that inside our Nest.js backend API. So let's do that. All right, in this section, we are going to integrate Google Authentication in our backend application, Nest.js. And then in the next section, we are going to use that functionality from our front end, Next.js. So in the Next.js application, our front end, with the help of our backend, the user can log in into our application with its Google account. So in the first step, we need to go to the Nest.js application, and here in the env file, we need to create 3 variables for the Google Authentication. So let me create a section here. I'm gonna name it Google Auth, and then here we need to have a Google Client ID, and then Google Client Secrets, and lastly, Google Callback URL. All right, so we need to get the value of the first 2 variables from the Google Console API, and for the third one, callback URL, we need to create a callback API endpoint in our application, backend application, Nest.js, and then set it inside the Google Console API. So now let's go to the Google Console API and get the client ID and secret. So here, as you can see, I'm in the console.cloud.google.com. And here you can choose an existing project or create a new one. So let's just create a new project here and just go with the default name and location. Click on the create here. All right, as you can see, the project is created, and let's select the project. And now I go to the API and services here. First, we need to go to the OAuth consent screen. So I click on that and choose external as a user type. You can learn about the user type here, but in short, internal users are within your organization and external users are everyone else, including the general public. So I choose the external and click on the create. Here we need to choose an app name. This will be shown on the Google login page. So here, for example, I'm going to say Sakura Dev Nest Next Auth. All right. And you need to put a user support email, and you can upload an app logo. And here, as the last thing, we just need to put the email address as developer content information. Just put my email. All right. And save and continue. Again, in this page, just click on the save and continue. Again, save and continue. And lastly, we have the summary, and I just click on the back to dashboard. Now I click on the credentials here and then click on the create credentials and choose the OAuth client ID. Then choose the application type, which is going to be a web application, and a name of the application. Just go with the default one. And this is important here. You need to put the authorized JavaScript origin. I'm going to put the address of the backend API. So here I'm going to say HTTP localhost 8000, which is the address of our Nest.js application. And then here we need to actually put a authorized redirect URI, which must be the same as the callback URL that we are going to put here. So let's get back to the Google Console API. Click on the authorized redirect URL. I'm going to say something like this: HTTP localhost 8000 and then /auth/Google and then /callback. All right. Just copy this because I want to put that inside the env file too. So let's create the credentials. Here, as you can see, we have the client ID and client secret. So let's get back to the VS Code. And first of all, I just paste the callback URL and then get back to our console API, copy the client ID, paste it here in front of the Google client ID, then get back to the Google Console API, and finally copy the client secret, and then get back here to the env file and paste it here for the Google client secret. So that's it. We have got the Google client ID and client secret, and we specify the Google callback URL. Later in this video, we will create a API endpoint with this route in our NestJS application, and you can see how we can get the user information from the Google Console API with this callback URL in our application. All right, now we need to create a config file for reading these configs from the env file. Let's save this, and I go to the configs directory in the Auth module, and let's create another file. I'm going to call it google-oauth.config.ts. All right, and then inside it, just like before, we're going to use register as function and a factory function to create a configuration object. So here I'm going to export default and then register as function. For the first parameter, we need to set a namespace. So I just use Google OAuth. All right. And then as a second parameter, we need to pass a factory function. This function should return an object. And inside this function, we're going to have the client ID, client secret, and also callback URL. All right. So we need to read the values of this configuration from the env file. So just use process.env.google client ID. For the client secret, I use process.env.google client secret. And for the callback URL, I use process.env.google callback URL. So that's it for the config file. And now we need to register this config file in our Auth module. So get back to the Auth module, and here, as you can see, we have registered the JDBT config and refresh config. So I just copy this and then pass the Google OAuth config. So finally, it should be config.module.forFeature function, and then pass the Google OAuth config, which comes from the Google OAuth config file that we have just created. All right, it's now registered in the Auth module, and we can use it inside the Auth module. Now we can create our Google OAuth strategy with Passport library, but before doing that, we need to install the Passport package for Google OAuth. So I open up the terminal, and I'm going to say npm I passport-google-OAuth20. And then we need to install the types of this package. So here I'm going to say npm I-d and then add types /passport-google-OAuth20. All right, so now let's create the Google strategy. So here inside the strategies directory, I'm going to create a new strategy and call it google.strategy.ts. And here we need to export a class, and I'm going to name it Google Strategy, which it extends the returning class of the Passport strategy function and pass the strategy. And this strategy actually needs to be imported from the Google OAuth. So as you can see, it is imported from the Passport Google OAuth. All right, and let's put the body of the class. And before creating the constructor of the class, let me mark it with injectable. And now inside the class, I'm going to create the constructor. And in the constructor, we need to actually call the super function. So here inside the super function, we need to pass a config object and set our client ID, client secret, and callback URL. As you can see, we don't have any autocomplete for this. So here, I just create a dummy instance of the Google strategy, const, for example, test, and set it to new strategy. And this strategy actually comes from here, Google OAuth 20, pass the config object. And here, as you can see, we have the autocomplete. So I choose the client ID, client secret, and callback URL. And lastly, we need to set the scope. So here, let me just copy the config object and paste it here. So now let's just remove the test instance. options. Now we need to set the values of these options from the Google config file. So we need to inject the Google config inside the constructor. So I use the @inject, and here I'm going to use the Google OAuth config.key and then private read only Google config and set its type to the config type and pass the type of the Google OAuth config file inside the generics. So just use the type of and use the Google OAuth config. All right, so now we need to set these values with this Google config. So set the Google client ID to the Google config.client ID, set the client secret to Google config.client secret, and set the callback URL to just Google config.callback URL. And for the scope, we need to determine the data that we need from the Google API. So we need to email of the user as well as the profile of the user. All right, so I set these two in a list and let's save this. And that's it for configuring the constructor. And now, just like the other strategies, we need to implement a validate function. So here outside of the constructor, I'm going to create a validate function. It should be async validate, and here we get the access token from the Google API, set it to string, and also refresh token, also set it to string. We got the profile. For now, we don't know the shape of the profile object, so we just set it to any. And lastly, we need to have a done function, which we set its type to the verify callback function, which needs to be imported from the corresponding package, which in our case is the Passport Google Auth. As you can see, we have the same type from the Passport JWT and other strategies, so make sure to import it from the right package. Okay, and then we need to create the body of the validate function. Let's save this to be formatted, and inside this function we need to call a auth service function for validating the Google users. So inside that function, we need to check if the user is already in our database. It means that it's not the first time that user is trying to log in into our application. So we have it already in our database. We just get back the data of the user from our database. And otherwise, which means that it's the first time that this user is trying to log in into our application with its Google account, we need to get the data of the user from the Google API and insert it into our users table. So now let's create this function. First of all, let me call it and then create that const user and set it to wait. And now we need to use the auth service. So we need to inject it in the constructor after the config file. We're going to have a auth service, private read only auth service, and set its type to the auth service class. All right, now we need to get back here and we can use the auth service class. And then, as I said, we're going to call a function which is not created yet. I'm going to name it validate Google user. And as you can see, we have an error here because this method does not exist in the auth service. So let me just declare this function. All right, now we can go to the auth service. It's really hard for me to pronounce auth service. And so I cut the function and get back here at the bottom of the auth service class. Here, let me mark it with async, and then inside it, we're going to have a Google user and set its type to the create user DTO. So if I get back to the create user DTO, you can see we should have name, email, and password inside it. So we can get the name and email of the user from the data that we're going to get from the Google API, but we don't have the password. So we just set the password to an empty string, and this causes a problem. I will show you what is the problem and I will come up with the solution. But for now, let's get back to our auth service, and here in the validate Google user, first of all, we're going to check if the user is inside our database or not. So I'm going to say const user and await user service, and then call the find by email function and pass the email of the user. So I just use the Google user.email. Now we're going to check if the user is not null. We just return the user. So it means that it's not the first time that user is trying to log in into our application. It already is inside our database. Otherwise, we need to insert the user into our user table. So again, just return and await this user service and call the create function, pass the Google user to it. So it will insert the user into our database and then return the user object back to this function, and we just in turn return it from this function. All right, let's get back to the Google strategy, and here we need to pass an object that should contain email, name, and password as its type, create user detail. So we're going to have email, and we're going to get that from the profile, and it is going to be from emails. It is a list, and then value. I will log the profile here, and you will see the shape of the profile object later when we're going to test this API. So we're going to have the name, and it should set from the profile that display name. And lastly, we need to set the password. As I said, we just want to set it to an empty password. But if we set the default password to a empty string, we need to get back to our local strategy where we handle user authentication with a username and password. We need to check if the provided password inside the incoming login request is a empty string. We need to return a unauthorized exception. So here I'm going to say if password equals to empty string, just throw a new unauthorized exception and say something like, please provide your password. All right. If we don't check that, a user with a valid email inside our database can log in into our application with empty password. And this is really insecure. So we're going to check if the user put a empty string in the sign-in page and tries to log in into our application with this trick. We're going to block that request with an unauthorized exception. So now we can get back here and set the default password of the user to an empty string. Later, we can provide a mechanism for a user to edit its default password. So now after we get the user, we need to call the done function, and it takes two objects. The first one is the error object, so we don't have any error here. And in the second, we need to pass the user object, and this user object will be appended to the request object under the property name user. So it is available on the request.user. And instead of using this done function, we can also just return the user object, and this is the same as the done function. It will append the user to the request object under the name user. And actually, this user here should not necessarily be with the name user. It should be any object, but finally it will append it to the request object on the property user, right? Let me in this case just use the done function here instead of directly returning the user. All right, so now we need to create a auth guard for the Google strategy. So I open up the terminal and I need to go to the Nest.js application because we are going to use the Nest CLI. So cd apps and then API. Right now we can use the Nest CLI, NestGU, which stands for guards. It is going to be on the auth directory and then guards directory. And then inside we're going to have a Google-auth guard and then set the no spec flag because we don't want to have the test file. Let's run that. All right. If I go to the guards directory, you can see now we have a Google Auth, and inside it we have the Google Auth guard. So just remove this section. We're going to export a class which needs to extend the auth guard, and this comes from the NestJS/passport, and then pass the name of the strategy, which is the Google. So that's it for the auth guard. And lastly, we need to register the Google strategy in the providers list of the auth module. So I just put the Google strategy here. All right, that is for configuring the Google authentication in our NestJS application. And now we need to just create an API for our front end. And then in the front end, we can call that API to start the authentication process with the Google. And then we need to create a Google callback API. So after the authentication process with Google is done, the Google API can call this API and sends us the data of the authenticated user. So inside the auth controller, we're going to have a GET request for logging in with Google. So use the GET decorator and set its route under the Google/login. All right, this GET API can be called from our Next.js application or front end to start the process of authenticating the user with Google OAuth. So we need to create a function for that. I'm going to call it Google login and put the body of the login. We don't want to put anything inside it. It's just an empty function. And all we need to do here, we need to mark it with the Google Auth guard. So I use @useGuards and pass the Google Auth guard that we have just created. So if we just call this API, the user will be redirected to the Google authentication page. And now we need to create a callback API. So we need to create another GET endpoint. We need to set its route under the Google /callback. And if I get back to our env file, you can see we set the Google callback URL under the /auth/Google and then callback. So here in the auth controller, as you know, all of the endpoints here are prefixed with /auth, and then we have the /Google/callback. So it is the same as the callback URL that we have specified in our env file and in the Google API console. It should be the same, otherwise we've got an error. So now we need to create a function for that. I'm going to just call it Google callback, and for now let's just put in empty, and all we need to do again, just mark it with the Google Auth card, just like the Google Login API. So this is the process. In the front end, we call this API. The request goes through the Google Auth card, and it will actually activate the Google strategy. It will redirect us to the Google login page. We choose our account, and then after the authentication is done, the Google API will call this endpoint, and it goes through the Google Auth card again and calls the Google strategy. And this time, Google strategy extract the data from the search queries of the incoming request and actually calls the validate function here in the Google strategy. And the important thing here, we should not send these access token and refresh token to the client. We are going to create our own JWT access token and refresh token. So the user needs to keep those access token and refresh token for calling the protecting APIs of this NestJS application. Don't send these two access token and refresh token that are created by the Google API directly to our front end. So as I said, after extracting the user data from the Google callback, this validate function will be called, and we can access to the user data under the profile. We validate the Google user, and then finally we send back the user object to the request.user. So in the auth controller, we can access to the user object from the request object. So for example, let me use the request decorator and define the rec here and just log into the console the rec.user. Let me create a title for that in the console. I'm gonna call it just Google user. And now let's test the Google login API. I open up the terminal. As you can see, our front end application, our Next.js, is running on port 3000, but in the main.ts of our NestJS application, you can see our backend application is running on port 8000. So let's get to the browser, and here, as you can see, let's go to the localhost 8000 and then /auth/Google/login, the login API that we have created in our backend application for Google authentication. So let's call this route, and as you can see, we are redirected to the Google sign-in page. This is handled by the Google strategy. I choose my Google account and here confirm that. Now you can see it actually calls an API on our NestJS application port 8000 /auth/Google/callback and pass the data of the user in the search query. So now let's get back to the VS Code and open up the terminal, go to the backend console. You can see the user object here. This user was already in our database, and you can see its ID is 4, and we have already set its name and its password, which, as I said, is retrieved from our database. If the user for the first time logging into our application, local strategy will insert that user into our database with this validate Google user function. So as you can see, the authentication process was successful with the Google strategy, and now we need to create our own JWT and access token, and then find a way to send these JWT and access token and the user object to the front end application, our Next.js application. So in order to do that, we need to go back to our Next.js application and create an API route for receiving the data from the backend. So from this Google callback API in the backend application, we can call that Next.js API and send the data of the user, its access token and refresh token to the Next.js application. And in that API of the Next.js, we're going to keep those data inside the session. So now let's go back to the Next.js application, and here in the APIs directory and the auth directory, I'm going to create a directory. I'm going to call it Google and then inside it, we're going to create a callback, and then inside it, we're going to create our route handler, route.ts. All right. So here I'm going to create a get function. So I'm going to say export async function get. We're going to have the request, which its type should be of type next request. And now inside it, we are going to extract the data of the user from the search prompts. So here I'm going to say const for now an object and create a new URL and pass the request.url. All right. So we're going to capture the URL here. And now from the URL object, we're going to extract the search prompts. Now from the search prompts, we're going to extract our data. So here I'm going to say const access token and set it to search prompts.get and expect it from the access token key. All right. In the same way, we need to extract the refresh token, and we're going to get it from the search prompts.get refresh token. We're going to get the user ID and set it to user ID. And lastly, we are going to get the name of the user and keep it inside a name constant. All right, now we need to check if these data are undefined. We're going to throw an error. So here I'm going to say if not access token or not refresh token or not user ID. We can also check the name here, but for now, let's just check these three. And then one of these are undefined. We're going to throw a new error and we're going to say something like Google OAuth fail. All right. Otherwise, we can now create a session object. So let's save this in here. We're going to call the create session function and pass the session object. Here we need to set the user. So we're going to set the ID to user ID, set the name to name, and we have an error here which says that the user should not be undefined. So let's check it here inside the if statement. Now the error is gone, and we need to set the access token and also the refresh token. All right, as you can see, it's working. And after creating the session, we can just redirect to the home page. So we can use the redirect function from the next/navigation and go to the home page. Now let's go back to our sign-in page. So I open up the auth pages and open the sign-in. As you can see, we have the sign-in form. And after the sign-in form, we are going to put a Google OAuth login. So I put in HR here. All right. And then after that, we're going to have our Google link. So I put in anchor tag and set the href to the backend URL and then /auth/Google/login. So this is the API that we have created in order to be called from our front-end Next.js application. And here in the caption, we're going to say something like sign in with Google. All right. And let's just put some class name here for starting the link. And it's really important that to use an anchor tag. Do not use a Next.js link here because we are going to call a external API in the Next.js application. It's on the backend API. It's not on the current Next.js application. So we need to put an anchor tag here. Let's save this. And now let's get back to our browser, go to our Next.js application. All right, localhost 3000. And for now, let's sign out first. Let's sign in again. You can see we have a sign in with Google. We need to set some styling to align it with this button. But for now, let's just test it. Click on the sign in with Google. You can see we are headed to the login page. Click on our Google account, confirm that. And as you can see, it calls the callback API from our backend auth/localhost 8000, the address of our Nest.js application /auth/Google/callback. It's on the backend. So we need to get back to our project. I go to our backend application, and inside the auth controller, this API was just called. So inside it, we need to call the Google callback of our Next.js application, our front end. So first, we need to create our JWTs. I'm going to create a response object and use the auth service.login function and pass the user ID, rec.user.id, and rec.user.name, right? So if I go to the login function, you can see first we're going to generate the access token and refresh token with the generate tokens function, and then pass an object that contains ID, name, access token, and refresh token inside it. So let's get back to the auth controller, and here we need to call the Next.js Google callback API and pass the data of the user along with its access token and refresh token. So in order to call our Next.js API, we're going to take the response object here, So I use the res decorator, and let's have the res object, and here we're going to use the res.redirect function. So we don't have the autocomplete here. For that, let's type the res object. It should be of type response, which comes from the express. All right, and here, as you can see, now we have the redirect function, and then here we're going to put the address of our Next.js Google callback. So it's in the localhost 3000, which is the address of our Next.js application. Of course, in the production, we need to replace this with the production address of our Next.js project, and then /API/auth/Google/callback. And as I said, this is the API route that we have created in the Next.js side, our front end. And then we need to set the search queries. First of all, we need to set the user ID and set it to response object that we have here, that user. So it's a promise yet. That's because we didn't use the await here, and we need to mark this function with async. All right, now we can use the response.id and then pass the name, then interpolate the response.name. Do the same for the access token and refresh token. Access token, and put the response.access token, and also refresh token, and put the response.refresh token. All right, so now let's save this and get back to our browser. Let's go to our Next.js application, click on the sign in with Google, choose our account, confirm that. As you can see, we are headed to the home page, and we have the name of the user here, and that's because here in the callback API of our Next.js application, so let me go to the /API/auth Google callback and the route.ts, the Next.js now. You can see we get the access token, refresh token, user ID, and name from the search prompts, and then create the session, and then finally redirect the user to the home page. And that's why we have the name of the user here, and we're authenticated and sign in with Google OAuth, which is handled by the NestJS application. You will see a lot of tutorial on YouTube that implement the Google OAuth authentication in your Next.js application with NextAuth. It is easily done, but when you have a separate backend project, you need to handle the Google OAuth in your backend application, and it's a little challenging, and I have the solution for you. That's it. And hold on, this is not the end of this video. Stay with me for the next part. You don't want to miss that. But if you have still with me up to this point of this video, please like this video and subscribe to my channel for more updates, tutorials, and courses. And feel free to share this video if you know someone that this video is useful for them. So now in the next section, we are going to add token invalidation, or revoking the tokens of the user in the backend side. So now we need to add a functionality to this application. When the user sign out from our application, we just delete the session of the user in the front end side in our Next.js. But the refresh token of the user is still valid for 7 days. And we need to actually invalidate that refresh token in the backend side. So that refresh token is no longer valid. We can do the same for the access token, but the access token of the user is only valid for 60 seconds or 1 minute. So we don't need to invalidate the access token of the user, but we need to invalidate the refresh token because it has a longer lifespan. So let's start doing that. I get back to VS Code, and in the Nest.js application, I go to the Prisma directory and open up the schema.prisma, and here in the user model, we need to add a column for storing the refresh token of the user. So every time we issue a refresh token for the user, first we're going to hash it and put it inside our user table for the user that we are actually creating the refresh token for. And then every time we are going to refresh the tokens of the user, we need to verify that refresh token with this refresh token that we are going to save inside the user's table. So I add a column here. I'm going to name it hashed refresh token and set its type to a string, and also we need to make it optional so it can also takes the null value. So let's save this and let's open up the terminal, go to the backend directory. It's on the apps and then API, and here we need to run a migration. So I'm going to say npx prisma migrate, and then dev, put a name for it, --name, and I say something like adding hashed RT. All right, it's done. And now we need to go to the auth service, and in the login function where we call the generate tokens function, we need to update the hashed refresh token field for that user. So in other words, after we generating the tokens, we need to first hash the refresh token and then save it inside the user table for the current user that we are going to create these tokens for. So in the first step, we need to hash the refresh token. So here I'm going to say const hashed refresh token. I just call it RT and then use the hash function of the Argon2 package. So I'm going to use await here and then use hash function, which needs to be imported from the Argon2 package, and then pass the refresh token that we've got here from the generate tokens function. Just put it here. All right. So now that we have a hashed refresh token, we need to put it inside the user table for the current user. So I'm going to create a function inside the user service, update hashed refresh token, and inside it actually I'm going to update the user table with the hashed refresh token. So here I'm going to use await user service that, as you can see, it doesn't have a update hash refresh token. So let's just call it and then we're going to declare it inside the user service. So it is going to be something like update hashed refresh token. We should specify the user ID that we are going to update its hash refresh token field and then pass the hashed refresh token value. All right, so let's declare this function and now let's go to the user service, just cut it from here and I'm going to paste it at the end of the user service class. Okay, now we're going to use the Prisma to update the hash refresh token field for the current user. So here just return an await Prisma dot users dot update function and pass the config object, specify where object in which we are going to specify which user record we are going to update. We're going to say update the record that its ID is equal to user ID parameter. All right, and then we need to specify the data in which we are going to specify the fields that we are going to update. So we are going to update the hash refresh token field and set its value to the hashed RT that we've got from the parameters. And also let's mark this function with async, and that's it. So now let's get back to our auth service, and inside the login function, as you can see, we are calling the update hash refresh token function, specify the user ID and hash RT value. So that's it for putting the hash refresh token inside its field in the user table when we are calling the login function and creating the refresh token for the function. As I said, you can also have a hashed access token field and store the hashed version of the access token if you have a longer span access token JWT. But in this application, we just set the lifespan of the access token to just 60 seconds. So actually, we don't need to invalidate the access tokens of the user when the user sign out from our application. It just automatically will be invalidated after 60 seconds. All right, we're not done yet in revoking the refresh tokens. We need to go to the refresh token strategy, and here in the validate function, we need to extract the refresh token from the body of the request, and then we're going to validate the refresh token inside the validate refresh token function. We're going to actually compare the refresh token that we've got from the request with the hashed refresh token that we have saved inside the users table. So now here, first we need to extract the refresh token from a body field because we expect it here from a body field under the field name refresh. So in order to access the request object, we need to set an option here, pass rec to callback and set it to true. And now we can access to the request object inside the validate function. So here we can have a rec and set its type to the request, which comes from the express. And now we can access to the request object, and from the body of the request, we are going to extract the refresh token. So here I'm going to say const refresh token and set it to rec.body and then .refresh. All right, that's because we put the refresh token inside a property named refresh in the body. Now we need to pass the refresh token to the validate refresh token function. So just feed it to validate refresh token function, and I go to the function and define the parameter refresh token and set its type to string. All right, now here after we get the user from the user service, we are going to compare the refresh token from the parameter to the user.hashed refresh token. So here I'm going to say const refresh token matched, and then call the verify function for comparing the refresh token and hash refresh token. So I use the verify function, which comes from the argon2. So if I scroll up here, you can see the verify function is coming from the argon2 package. All right, now in the first parameter, we need to pass the hashed version of our refresh token. So I'm going to set it to user.hashed refresh token. And the second parameter, we need to pass our plain refresh token, which we've got from the parameter. All right, now it is very important to put the await here, because if you don't, it just return a promise, and that refresh token matched always have a true value. All right, so don't forget to put the await here to get the resolved Boolean value. Now we're going to check if refresh token is not matched, so not refresh token matched. We just throw an unauthorized exception just like this. So let's just copy that and put it here. Just need to change the message. We're going to say something like invalid refresh token. All right, now we can return the current user, which is an object that just contains the ID of the user. So in this way, in the validate refresh token, we not only validate the user, we validate the refresh token with the hashed version of the refresh token inside our database. Now let's get back to our refresh token strategy, and we're done. We just need to return the user object from this validate function that we've got here from the returning object of the validate refresh token function. So when we pass through the refresh token strategy, the request for refresh token get through the refresh token API. And here, as you can see, we call the refresh token function to generate the new refresh token for the user and return it back to the user. Now here, we need to update the hash refresh token in our database with the new refresh token that we got from the generate tokens function. So just like the login function here, just copy these two lines of code, get back here to the refresh token function, and here we just hashed the refresh token and then call the user service.update refresh token of the function, specify the user ID, and pass the hashed version of our new refresh token. Now our revoking of the refresh token process is complete. Now we're almost done with the invalidating the user's refresh token function. We just need to put the first puzzle of the invalidating refresh token just in place, and that is creating a sign out function. So when the user on the client side click on the sign out, we just delete this session of the user in the Next.js project, but also we need to sign out in the backend side and invalidate the refresh token of the user. So I go back to the Auth controller and create a API endpoint for sign out. So here we're going to have a post endpoint and set its route under the /auth and then /sign out and create a function for that. I'm just call it sign out and put the body of the function. We need to mark it with JWT guard. So I use guards here and pass the JWT auth guard. So only the signed in users can call this API. Now, since we have marked it with the use guard and passed the use auth guard, our request object has a user object. So let's access to the request object with the @rec and use the rec here. Now we need to create a function inside the auth service, pass the user ID, and within that, we're going to invalidate the refresh token. So I'm going to say return this.auth service and just call the sign out function. We haven't created that. We're going to create it in a second and pass the rec.user.id. Note that if we don't mark it with the JWT auth guard, we cannot access to the user object. All right, so now let's just declare the sign out function inside the auth service. Go to the auth service and got the sign out function, paste it at the bottom of the class. Now just change the parameter name. I'm going to call it user ID and I'm going to type it with number. And now we need to call the update hash refresh token function of the user service and pass null as the hashed refresh token. So we put null inside the hashed refresh token for this user. So when the user sign out, its hashed refresh token field is null. And if somehow someone gets its refresh token, which is valid for 7 days, and tries to refresh the token and get a new access token, with that compromised refresh token, it cannot refresh the token because we set the value of the hash refresh token inside our database null. And when in the validate refresh token function here, we are going to verify the provided refresh token with the user hash refresh refresh token inside our database, this function returns false because this parameter is null, and here we just throw an unauthorized exception and say invalid refresh token. That is the first puzzle of revoking refresh token process. So here in this sign out function, we need to set the hash refresh token of the user to just null value. So I just return and call the user service.update hashed refresh token. So await user service.update hash refresh token, pass the user ID, and for the hash refresh token value, we just set null value. And let me mark this function with async, all right, and go to the update hash refresh token and just set the type of the hash refresh token to a union, string, or null. All right, let's save this and get back here. That's it. We just need to set the hash refresh token of the user to null, and now the refresh token of a sign out user is not valid anymore, although on the paper it is still valid for 7 days. That's it for invalidating the tokens of the user in the backend side. And now we need to just go back to our Next.js side, and when the user sign out, just call the sign out API from the backend. So in the sign out route, before deleting the session, we're going to just send a request to the backend side and call the sign out API. So I use auth fetch because we need to have a JWT inside our request, and set it to a response, const response equals to await auth fetch, and put the backend URL, and then /auth/sign out, and then pass in config object and set the method to post. All right, and then here we can check if the response is okay. We can actually delete the session of the Next.js. All right, so let's save this and get back to our project. If I click on the sign out, it calls the sign out route inside the Next.js, this API handler that is on the API/auth/sign out. And as you can see, we just send a post request to the sign out API, and then if the response is okay, we just delete the session. So we are actually signing out both from the front end side as well as the back end side. All right, so now let's just sign out, and as you can see, the session is deleted. And before we delete the session, we make sure to sign out from the backend side. And now let's run the Prisma Studio to see if the user has a null value for its hashed refresh token. Get back to VS Code and let me create another terminal. Go to the backends directory. It's inside the apps/API. Now we can run the Prisma Studio here, npx Prisma Studio. All right, and here, as you can see, we have a null value for our user. So let's get back here and sign in again. Okay, now let's get back to the Prisma and refresh the users table. Now you can see we have the hashed refresh token for the user number 3. So now let's sign out again, get back to the users table and refresh the table. As you can see, the value is null now. Now let's get back to the browser, and this time let's test it with the Google Authentication. Let's sign in and choose our Google account, confirm. All right, now let's get back to the users table and refresh the table. Now again, as you can see, we have the hashed refresh token inside our users table. And for the last time, let's just sign out. Okay, get back here and again refresh the table, and yeah, as you can see, the value is now null. So yeah, that's it for handling the sign out from the client side as well as the backend side. We have not only delete the session in the Next.js, but also invalidate the refresh token of the user on the backend side, our Next.js project. But hold on, this video isn't over yet. Stay with me for the next part of this video. You don't want to miss them. We are going to cover the public routes and global authentication in our Nest.js application, our backend, and also we are going to implement a role-based access control or role-based authorization in our application and handle it both in our Next.js and NestJS project. So before moving to the next section, please hit the like button, and if you haven't subscribed to the channel, you can consider subscribing to my channel for updates and upcoming courses and tutorials. Thanks for your support. I really appreciate that. All right, so now let's go and enable the global authentication in our NestJS application. So what does that mean to enable global authentication in NestJS? So let me show you with an example here in the Auth controller. You can see if we want to protect an API, we need to mark it with the use guards and then pass the JWT auth guard. So we just have one protected API, but in a real world application, you might have a really big set of APIs that need to be protected. So you need to manually mark all of them with useGuard and pass the JWT auth guard. But there's a better way, and that is enabling the global auth. So by default, we are going to protect all of the routes inside our application with a specific guard, or we can have also multiple global guard, which means that guard all the APIs in our application with multiple auth guards, and then we don't have to manually protect APIs with useGuard. So by default, all the APIs are guarded, and then we need to just exclude those APIs that should not be protected, like sign-in API or other APIs that should not be protected by the specific auth guard, which is here in our case JWT auth guard. So in this section, first we are going to enable the global auth with the JWT auth guard, and then we're going to exclude the public routes from the global authentication. So in order to enable the auth guard, I go to the auth module, and inside the provider, I'm going to add a custom provider. So I add an object and set the provide to app guard token. So this token app guard is a special token or constant provided by the NestJS to allow you to set up a global guard. So it means that you are going to applying a specific guard for all of the API endpoints inside your NestJS application. So in the second property, we need to set the use class, which means that which specific guard are you going to apply on all of your APIs. So we are going to apply the JWT auth guard. So let's just pass it here. And now all of the APIs in our application are guarded with the JWT auth guard. All right. So let me get back to the auth controller. We can remove the JWT guards here, and also here, these are by default are guarded with the JWT auth guard. So here, doing something this means that we are going to use at useGuard and then pass the JWT auth guard on all of the APIs of our application. All right. So let's save this and get back here. So now we have a problem, and that is these APIs for login and for the callback are also automatically protected by the JWT guard. So if I save that and get back to the browser, you will see I have a problem for calling the sign-in API because it is also now protected by the JWT auth guard. So now get back to the browser. If I click on the sign in and sign in, you can see invalid credentials are on the sign in page, and that's because our sign in API is also guarded with the JWT guard, which expect us to have a JWT access token in the header of our request, which is not desirable for the sign in API. So we need to exclude these API routes from the global auth system, which is now guarded by the JWT auth guard. In order to do that, we need to set a metadata for our public routes, and then inside the JWT auth guard, we need to check them if a API endpoint has the public metadata. We just need to bypass the JWT auth guard. So in order to do that, we can just say something like this. We can say here at set metadata and then pass a key here, for example, is public, and then pass its value to true. All right. It's okay to set the metadata, but let me be more specific and create a custom decorator, for example, at public, and then we're going to just call this set metadata. And then instead of this, we can apply the at public decorator. So in the auth directory, I'm going to create another directory and call it decorators. And inside it, we're going to have a public decorator. So I'm going to create a file public.decorator.ts. And here we just need to create a function which applies the set metadata function. So here I'm going to export a function. I'm going to call it public. All right. And then it should use the set metadata function. And we're going to specify a key. So it is better to store the key inside a constant and then export it, because later we need to know the value of the key. So export const is public key and set its value to just is underscore public. All right, now we can use this is public key and set its value to true. And we need to have a assignment sign here. All right, now if we use at public decorator on any of our API routes, it's just like using the at set metadata decorator with this is public key and a true value. So now, for example, let's get here, and for the sign in API, instead of this set metadata decorator, we're going to just use at public and make sure to import it from the public.decorator file. All right, now let's just apply this decorator on all of the APIs that does not need to be protected by the JWT card. Okay, so let's just mark refresh token with this public, and also Google login and Google callback. All right, actually all of these APIs are still guarded with the JWT auth card. We just set a metadata with is public key and a value true to the public API routes, but they are still guarded with the global guard system. So in order to fix that, we need to go to the JWT auth card, and here we need to check if any API route is marked with the public. We need to just bypass the JWT auth card. So we need to do this check inside the body of the JWT auth card. So we're going to have a constructor, and inside the constructor, we need to actually inject the reflector class. So I'm going to talk about what it is, but for now, let me just inject it, private reflector, and set its type to the reflector class. All right, now inside the body, we just need to call the super function. Okay, and now we need to implement a can activate method, which essentially determines if an incoming request can pass this guard or not. If we return true, it means that the incoming request can pass this guard and reach the protected resources. And if we return false, it means that we actually block the incoming request. All right, so we're gonna have can activate. So as you can see, it has a execution context. So here inside it, first we need to check if the API routes is marked with the at public decorator, and we're going to do that with the reflector class that we have injected here. So this is one of the functionalities of the reflector class. So I'm going to say const is public and set it to this get reflector get all and override, and we're going to pass the returning value, which is going to be a boolean. I set it to boolean because here in the at public decorator, we just set the value of our set public key to true, which is a boolean. All right, so that's why we set it to boolean here. And then we need to pass our metadata key. So if I get back to the public decorator, you can see we have used the is public key as the key of our metadata. So we need to use the same key to get its value. So we're going to pass is public key, which comes from the public decorator, and then here we need to specify from where we are going to get this set metadata. So pass a list here, and here we're going to set the context dot get handler and then context dot get class. So what does that mean? The context dot get handler checks the metadata on a specific API route handler. For example, in the auth controller, we can see we set the set metadata with at public decorator on the API handler itself. Also, we can mark the entire controller class with this at public, which actually set the metadata on the entire class. So now all of the endpoints here are marked with the public decorator, and here in the JWT auth card, first we are checking if any specific metadata with this key is set on the API handler, and if it's not, we check the entire metadata of the class for this public key. And actually we are setting the high priority on the get handler because we set it first. So that's it for getting the metadata of the handler, and we're going to check if the value of is public is true. We just return true, and this means that just bypass the JWT auth card. So here I'm going to check if is public, just return true. All right, otherwise if we don't have any metadata on this key with the value of true, we just activate the JWT auth card. So we just return super class that can activate function and pass the context to it. All right, so in this way, if any of our API routes is marked with the at public decorator, it is actually excluded from our global auth system. So now let's save this And here, let's remove the add public on the entire class because we don't want to exclude all of its API routes from the global authentication system. Let's save this and get back to our browser. Now, if I click on the sign in, you can see I can access to the sign in API. So let's get back to the auth controller. And here, as you can see, we don't use any guards in the protected APIs. And also we haven't marked it with the add public decorator, which means that it is by default is protected by the JWT auth guard. So let's get back to the browser and go to the profile page, which sends a request to the protected API to see if it can access to our APIs or not. If I click on that, you can see now we can access to this protected API because we are signed in. And that's it. We have enabled the global authentication in our backend application. So now in the next section of this video, we are going to implement role-based access control or role-based authorization both in our NestJS application and in the Next.js application. So if you haven't liked this video so far, I think now it's best time to hit that like button and give me more energy to move forward and create such a long tutorials for you. So let's get into it and implement a role-based access control. Alright, now in this section, we are going to implement the role-based access control in NestJS. And then in the next section, we are going to extend it to our Next.js application. But now let's just focus on how we can apply it in our backend application, the NestJS project. So this is the whole process of role-based access control in our NestJS project. First, we need to add a role field in the user model to define the role of the user. Inside our application, we can have multiple roles, for example, a normal user, admin, a editor, and so on. Then we are going to define the authorized roles for each API endpoint. For example, an API endpoint can only be accessed by an admin user. The other one can be accessed by admin and editors, and the other one can be accessed by all of the users. So we're going to specify for each API endpoint what are the authorized roles. And then when the user tries to access an API endpoint, we're going to check if the role of the user is one of the authorized roles for that specific API endpoint. If that's the case, we can allow the user to access that API. Otherwise, we just throw an unauthorized exception. So let's get back to our NestJS application and start implementing the role-based access control. I get back to our NestJS project, and here in the first step, we need to add the user role in the Prisma schema. So I open up the Prisma schema, and inside it, first we need to define a role enum. So here I'm going to say enum role, and then inside it we're going to define the roles of our application. So for example, let's say our application only has admin users, editors, and also the normal user, which I'm going to call them user. All right, so this is our role, and now we need to go back to the user model and add a field inside the users which specify the role of the user. So here I'm going to add a field, call it just role, and set its type to the role enum. And also we need to add a default value and set the user for the default value. So that's it for the Prisma. Now we need to run a migration. Let me just open another terminal, go to the NestJS application, apps, and then API. All right, now let's run a migration, npx prisma migrate dev, and then -- name. For its name, I'm going to just say something like adding user role. So let's run that. All right, so let's close this off. Now we need to go to the strategies here and add the user role in the returning object of each strategy. So let's start with the local strategy. In the validate function, it returns the returning object of the validate local user. So here, as you can see, it returns just the ID and name of the user. So we need to add the role inside it. So put a role key and set its value to the user.role. And just to remind you, the user object comes from the database. All right, we need to do that with the JWT strategy and Google strategy. So I go to the JWT here, and here we call the validate JWT user in the validate function and put the role of the user, all right, and go to the Google strategy. Here we call the validate Google user, and it actually return the entire user object which already contains the role of the user. So that's it for adding the user role in the user object. And now we need to find a way to specify the authorized roles for each API endpoint. So in order to do that, I'm going to create a roles decorator in which we are going to use the set metadata function, just like the public decorator that we have created in the previous section of this video, and actually use the set metadata function for defining the authorized role of each API endpoint. So here in the decorators directory, I'm going to create another decorator file. I'm going to call it roles.decorator.ts. All right. Now here we need to export a decorator function. I'm going to call it roles and set it to a function. And inside the roles decorator, we need to get a list of roles and then set the metadata. So here we're going to say roles is going to be a list of roles. So role comes from the Prisma client and it is going to be a list of them. And then we are going to use set metadata function and we need to specify a metadata key. So let's just keep it inside a constant because we need that key later to see the required role of the API endpoint. So I'm going to just export it, export a constant, call it roles key and set it to just roles. All right. Now in the set metadata, we specify the roles key and then put the roles array here. All right. So this is the roles decorator. Now, for example, we can go to our controllers and use the roles key for our API routes. So here we have the protected API, which is this one. And here we can use the roles decorator. And let me just import it from the roles decorator. Inside it, we can pass a list of roles. For example, we can say that only admins and editors can actually run this protected API. So as you can see, the roles needs to be inside the list. So let me go back to the roles decorator and use the REST operator here. And now here we can just take the roles without a list. So actually this REST operator here packs all the parameter to this function as a list and feed them to the roles parameter, which is going to be a list. And now let's make this function even better. So if I get back here and specify nothing inside the roles, you can see there is no error, and that's because we can have a empty array. So in order to avoid taking a empty array here, let's change the type of the roles. Here I'm going to use a tuple, and in this tuple we should have at least one role, and then we can have 0 or more elements of type role. So I put the REST operator and use a role list here. So this tuple means that the array should at least have one element. So let's get back to the auth controller. You can see we have an error here, and if we provide at least one element, you can see the error gone. We can also provide multiple elements as well. All right, so this is the roles decorator. You just set the required role of an API with the set metadata function. Now we need to create a roles guard, and then inside it we're going to extract the required roles from the metadata of the related API, and then we're going to check if the role of the user is one of the required roles. So let me open up the terminal and create the roles guard. So I go to the apps and then API. Now we are in the NestJS project. We can use NestGU, which stands for guards. It is going to be inside the auth and then guards directory, and then it is going to be roles guard, and then specify the no spec because we don't want the test file. All right, so let's create that. You can see now we have a roles directory inside the guards directory, and inside it we have the roles.guard.ts file. And here in this guard, first we need to extract the metadata for the roles. So we need to use the reflector class. I'm going to inject it in this class, private reflector, and set its type to the reflector class. Okay, now here in the can activate function, we need to get the required roles of the related API. So just remove this return here from the can activate function. First of all, I'm going to just extract the required roles from the reflector class. So this that reflector that gets all and override, and then we're going to specify the returning value. It is going to be a list of roles, and then specify the metadata key. It is from the roles key that we have defined inside the roles decorator, and then specify where we are going to get this metadata. First, we are going to get them from the handler. So I'm going to use context get handler, and then if it's not in the API route handler, we're going to look to the metadata of the controller class. So is context get class. Now we need to check if there is not any required role specified for the current API. We just return true and allow the user to access the resource. So here I'm going to say if not required roles, we just return true. Otherwise, we need to check if the role of the user is one of the required roles of the current API. So first we need to access to the user object. I'm going to say const user equals to context. And by the way, this context comes from the parameter of the can activate function that switched to HTTP because our incoming request is a HTTP request, and then call the get request function. And now we can access to the user object. And here's very important point. We need to use this roles guard after the JWT auth guard. You might ask why? Because we want to access to the user object, which only be available in the request object after the JWT strategy has been run. Otherwise, we don't have any user object in the request. So make sure to use the roles guard after the JWT auth guard. Alright, so after getting the request object, we're going to check if the role of the user is one of the required roles. So here I'm going to say const has required role and set it to required role and call the sum function. So in the sum function, we're going to loop through each element of the required roles, and then for each role inside the required roles, check if the role of the user equals to the current role. So here I'm going to say user.role equals to role that comes from the parameter of the callback. So if for at least one of the required roles here, this expression is true, we can say that the user has one of the required roles. So the sum function return true if at least for one element of the required roles, this expression holds true. And that means the role of the user matches with one of the required roles, and we need to allow user to access to the protected APIs. So we just return the has required role. If the sum function returns true, we just return it here and allow user to access the protected resource. Otherwise, if it returns false, again, we return it and actually block the incoming request. All right, that's it for the roles guard. And now let's get back to our controller and show you how you can use this roles guard. So here, there is an important tip here. We already have enabled the global authentication with JWT guard. But suppose that we haven't enabled the global authentication, and if we want to protect an API, we need to mark it with the JWT auth guard. So here, I'm going to use useGuard and pass the JWT auth guard. And as I said, after the JWT auth guard, we need to use the roles guard. So then here, before the use guard, we're going to put the roles guard. All right. So why we use it before it, I just say use it after it, because the decorator here works as a wrapper. And this function finally sends to the immediate decorator as a callback. So first, the getAll function is sent to the getDecorator as a callback, and then it returns a function. And then the returning function of this decorator will be something like this, and then will be sent to this useGuard as a callback, and then the returning function of this useGuard will be sent to this useGuard function. So first, JWT auth guard is run, and after that, the roles guard is going to be run. All right. So if you use the decorator, just use the roles guard before the JWT auth guard, and it will be run after the JWT guard. And you might ask why we need to put the JWT guard in the first place, because we need to have a user object appended to our request object. So then inside the roles guard, we can access to this user and check the role of the user. All right. That's why we need to first apply a JWT guard. So as you know, we already have enabled the global authentication, so we don't need to use the JWT Auth guard. And if you want to add the roles guard in the global authentication system, you need to do this. So go to the Auth module, and here, as you can see, we have an app guard. We are going to use another custom provider with the app guard token. And this time in the use class, we're going to just add the roles guard. All right, so that's it. And it is going to be something like this: use guard with the roles guard in every APIs in our application. All right. And let me remind you that there is another important tip here. If you want to use global authentication, you need to register the roles guard after the JWT. So this scenario is the opposite of the situation when we don't have the global authentication and we want to manually use the use guards. In that situation, when we are going to use manually use guard decorator, first we need to add the roles guard, and then in the next line we need to apply the JWT Auth guard. But here in the global authentication, first we need to register the JWT Auth guard, and then after that register the roles guard. Otherwise, we've got an error in the runtime. I will show you the error in the next section when we are going to test this. So we have the roles guard in the global authentication, and we don't need to use this. And here, note that the roles guard will be applied only for the routes that we have used the roles decorator, which is for setting the metadata of the user role. That's because if I get back to the roles decorator, in the first line, we check if the current API doesn't have a required role in its metadata, we just return true and allow the user to access the API. So this guard only works for the APIs that have some required roles with the roles decorator. So now let's test this API. First, let me open up the Prisma Studio to see the roles of each user. So I'm going to say npx Prisma Studio. All right, so this is the users table, and as you can see, all of the users for now have the role user. So let's get back to our application. Now let's go to the profile page, and you can see we have a forbidden resource error. That's because this page will send a request to the protected API here, and this is only available for the admin user and editor. That's why we have a forbidden error. So now let's get back to the Prisma Studio and change the role of this user to admin. Let's save the changes. All right, now let's get back to our application and refresh the profile page. Now, this time we can access to the protected API because our user now has a admin role. All right, so that's it for handling the role-based access control in the NestJS side. And now we are going to extend it to our NextJS application. And the use case is very simple. Let's say we want to only allow the admin user to have access to the dashboard page. The normal users should not have access to the dashboard page. So let's get back to the Prisma Studio and change the role of the user to just user. All right, now let's get back here. Let's sign out, sign in again. Now, if I click on the dashboard, you can see we can access to the dashboard, but we are going to check the role of the user and only allow the admin user to access this page. So let's do that in the NextJS side. In the first step, we need to add the role of the user in the session type, and then we're going to get back to the NestJS side, our backend, and include the role of the user in the returning object of the sign-in API. So let's get back to our application, and here we're going to get back to the NextJS application. I go to this session, and here inside the session type, we are going to add a role, which its type should be type of role. So we can't have access to the roles type because that was on the backend. So let me just manually export a role type. So here I'm going to say export enum and name it role. And inside it, we're going to have the admin, editor, and user. So this is our role type, and get back to the session type and set the role of the user to the role enum that we have just created. All right. Now we need to get back to our NestJS application, our backend, and go to the sign in and also Google callback and include the role of the user in these two APIs. So first, let me go for the sign in API. I go to the login function, and here we're going to just have a role inside it, and we need to set it to the role of the user. So we need to get the role of the user, which is going to be a role, all right? And here we need to set it to the role of the user, or we can just include it in the returning object. All right. You can also create a user object and pack the ID name and the role inside it, just like the session type. But for now, let's just leave it as it is. And now we need to get back to our auth controller. Here in the sign in, we have the user object, and we have already included the role of the user to the returning object of the local strategy. So we can add the role of user here from the rec.user.role. All right. Now let's go to the Google authentication here, Google callback. Here we already needs to put the role of the user here. So just like the sign in function, I'm gonna put the rec.user.role to the login function. All right. Now the response object contains the role of the user, and we just need to include it in the search queries. So we're going to add a role search query and set its value to the response.role. All right. Now let's get back to our Next.js application. First, we need to handle the sign in. So I go to the auth.ts, and inside the sign in function, this is the sign in function. And here we already have an error for the create session. We need to include the role of the user. I'm going to set it to the result.role. So that's it for sign in. And this result is actually the response of the post request to the sign in API in the backend side. We just have include the role inside its response. Right now we need to handle the Google authentication and include the role inside it. So here I go to the Google callback here, and here first we need to get the role from the search query. So it is under the name role, and just I'm gonna call it role here, and let me check it if it has a undefined value. Just throw an error, the error here. Okay, now we can just add the role here for the user object. So we're going to set the role to the role value that we've got from the search params, and we need to cast its value to the role enum. All right, that's it. And now this session has the role inside it. So if I go to the home page of our application, let me just get this session and log this session to see if we have the role inside this session. So we need to first sign out, and then let's sign in. All right, now let's get back to our console terminal, and here as you can see we have the session here, and we have the role of the user included in the user object of the session. All right, now let's test it with the Google authentication. Get back here, let's sign out, and let's sign in here with Google. Choose our account, confirm that, and now let's get back to the terminal. And here as you can see, now that we have the role of the user inside this session, we can apply the role-based access control in the Next.js side. So let's close this off and let's go to the dashboard page, and here as you can see we get this session, and we can double check the role of the user. So we can say if session.user.role is not equal with the role.admin, we can just again redirect the user to the sign-in page, or have a specific error message, for example, you are not authorized or something else. All right, so let's save this and let's get back to our browser. Now if I go to the dashboard page, even if I am signed in, I am being sent to the sign-in page. So let's go to the Prisma Studio and change the role of the user to admin. So here, change the role to admin and save the changes. Now get back here, and first we need to sign out and sign in again. Now if I go to the dashboard page, you can see I can access to the dashboard page because now the role of the user match with admin role. So yeah, that's it, the way that you can implement role-based access control in Next.js. You need to have the role of the user inside your session, and then for each page you can check the role of the user. So yeah, that's it for this comprehensive tutorial. We have created a monorepo with Turborepo with two projects, NestJS and NextJS, and we implemented the authentication in these two projects. So if this video was helpful for you, please hit the like button and also subscribe to the channel for more comprehensive tutorials like this. I'm going to create more full stack projects with Next.js and NestJS in this channel. So make sure to subscribe to the channel to get informed about those comprehensive projects. And if you think this video is helpful for your friends or colleagues, feel free to share it with them. All right. Have a nice time. Bye bye.